So in this lecture we are going to learn about the probability formulas of mathematics in a detailed manner. So the probability is nothing but here, suppose the probability of an event is equal to, it is the ratio of the number of outcomes of event by number of outcomes of the experiment. It indicates that suppose there is some event out of a sample space. So if you do some experiment, you are going to get a total amount of data. The data we are going to call it as a sample space. See, out of this total sample space, we are going to focus only on one particular event. The number of outcomes which are going to in favor of the event by the total number of outcomes of the experiment, or simply we can say the total number of outcomes in the sample space, the number of things which are going to present in the sample space. So therefore the probability of any event is equal to the number of outcomes or in favor of the event by total number of outcomes of the experiment. Or simply in another format also we can write, which is it is equal to the ratio of the area covered by the event by the area covered by the outcomes of the experiment. So you can go for any of these things, still you are going to get the same result. It is going to depend only on where you are going to use them. So we can say clearly the probability of event is equal to the number of outcomes of the event by the number of outcomes of the experiment, or we can say simply the area covered by the event by the area covered by the outcomes of the experiment. So now you can see here there is a Venn diagram. Here there is a Venn diagram. This Venn diagram indicates that this whole box is going to indicate that this is the way that the overall things are going to occur in an experiment. Means it is going to cover each and everything of an experiment. So out of this, I am going to consider only one particular event that is called as E. So therefore, the probability of event E dash, or we can say E bar, is equal to 1. Always the probability of event occur plus the probability of event not to occur is equal to 1. So therefore, I am going to assume the probability of event E is equal to m by n. Means m is the number of outcomes which are in the favor of the event, whereas n is called as the total number of outcomes of the experiment. Then definitely we can say the probability of E bar is equal to, if you substitute the probability of E is equal to m by n, and if you do simplification, we are going to get n minus 1, n minus m by n. So therefore simply we can say 1 minus m by n is equal to n minus m by n, or we can say simply n minus m indicates that the number of outcomes which are unfavored to the event E by the total number of outcomes n. See, there is also one more point, which is the odd in favor of event. It indicates that odd in favor of event means it is the ratio of the number of outcomes favor of event by the number of outcomes unfavor of event. See, the odd in favor of event means the number of outcomes favor of the event by the number of outcomes unfavor of the event. So I have already told you, for event E, the number of outcomes are, or we can simply say that the number of outcomes in the favor of event E is m, whereas the number of outcomes unfavor of event is n minus m. So therefore just you have to do the ratio of these things in order to get the odd in favor of event. But if you want to know what is the odd in against of event, it indicates that it is the reverse of this one. So therefore the number of outcomes unfavor of event by the number of outcomes favor of event. As I have already told you, the number of outcomes unfavor of event is n minus m, whereas the number of outcomes favor of event E is m. So therefore just you have to go for the reverse process. So odd in favor of event means the number of outcomes in favor of event by the total number, or we can say the number of outcomes unfavor of event. But if you want to know what is the odd in against of event, means the number of outcomes unfavor of event by the number of outcomes favor of event. It is the meaning of these things. So some rules in the probability are, which is always the probability of any event is always going to lie between 0 to 1. Means the minimum value can be 0 and the maximum value can be 1, but it cannot exceed more than these values. So therefore it always has to lie between the 0 to 1, whereas the probability of the sample space is always equal to 1. Means if you take any sample space, definitely we can say out of sample space any event is going to get occur. So simply we can say the probability of sample space is always equal to 1. So now we are going to study about the dice. Basically a dice is going to have total 6 faces. So the total number of faces for a dice are 6. So it is 1, 2, 3, 4, 5, 6. So therefore 6 number of faces are going to there. So one dice throw n times is equal to n dice thrown together is equal to the total number of outcomes are 6 to the power of n outcomes. It simply indicates that suppose if you are going to throw one dice thrown n times is equal to n dice thrown together is equal to the number of outcomes are 6 to the power of n outcomes. Or we can simply say that, see, definitely one dice is going to have 6 faces, means 6 outcomes. So if you are going to throw one dice for n times, so for one time the number of outcomes are 6. So definitely you have to multiply 6 n number of times. So 6 into 6 into 6 into 6 up to n times. Or simply we can say 6 to the power of n. Or we can simply say that the total number of, or we can say the sample space is going to contain total 6 to the power of n outcomes when you are going to throw the one dice n times. Or in another way we can also say that if you are throwing n dice for one time, if you are going to throw n dice together in one time, then the number of outcomes or sample space is going to contain 6 to the power of n outcomes, because each dice is going to have 6 outcomes. So therefore 6 into 6 into up to n times is equal to 6 to the power of n outcomes. So now we are going to learn about some special condition, which is special case when 2 dice rolled. Suppose when you are going to roll the 2 dice, only 2 dice, then what are the number of outcomes we are going to see? See, suppose I want to know only sum 12. See, the minimum number of the dice is 1 and the maximum number of the dice is 6. So definitely the minimum sum will be 1 plus 1 is equal to 2, and the maximum sum can be 6 plus 6 is equal to 12. So therefore the sum can lie, means that the numbers which are going to present on each dice, if you add, you can get minimum number of sum 2 and the maximum sum of 12. So therefore you can write the sum in this manner: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So therefore now you can see clearly the number of outcomes for sum 2 or sum 12, which is 1, and the number of outcomes for sum 3 or sum 11 is 2, and the number of outcomes for sum 4 or sum 10 is 3, whereas the number of outcomes for sum 5 or sum 9 is 4, whereas the number of outcomes for sum 6 or sum 8 is 5, and the number of outcomes for sum 7 is equal to always 6. So therefore 2, 3, 4, 5, 6, 7, and here 12, 11, 10, 9, 8. So here take in the increasing order 1, 2, 3, 4, 5, 6. Or simply we can say, tell me what is the probability of sum 2. Therefore we can say the number of outcomes are 1, but total number of outcomes is 6 square, because each dice is going to have 6 outcomes. So 6 into 6 is equal to 36. So therefore we can say 1 by 36 is the probability of the sum 2, or the probability of sum 12 is also 1 by 36. So like this we can go for this one. So therefore whenever the special condition is when 2 dice are going to roll, the number of outcomes are 6 square. So out of this I want to know the probability of sum 2 or sum 3 or sum 4 or sum 5, sum 6, sum 7, all these things we can figure out from this diagram or from this table. If suppose the coins are there, so now we are going to learn about the concept of coins. One coin tossed n times is equal to n coins tossed together is equal to the number of outcomes up to the power of n outcomes. Same thing as the dice, because a coin is going to have 2 sides, so therefore we can say 2 outcomes for one coin. But if you are going to throw one coin n times, the number of outcomes will be, for one coin the number of outcomes are 2. So if you are going to throw it for n times, then definitely you have to multiply 2 for n times. So therefore 2 to the power of n is the total number of outcomes if you are going to throw one coin for n times. Or in another format, if you are going to throw n coins in one time, the number of outcomes will be same as the previous one, which is the 2 to the power of n outcomes. I want to know the probability of k heads, the probability of k number of hits are going to occur. Then we can say nck by 2 to the power of n, because if you are going to throw n coins, in one time, definitely we can say the number of outcomes are 2 to the power of n. Out of these, I want to know only k number of hits. I need only k, particular k. Out of n, I need only k number of hits. So therefore we can say this is the number of outcomes in the favor of the k number of hits is nck. So therefore you have to go for the division of the number of events favored by total number of outcomes, which is nck by 2 to the power of n. So now we are going to learn about the concept of cards. See, basically a card pack is going to have total 52 cards. So out of this, we are going to split into 4 parts. They are going to split into 4 categories. Now we are going to learn about the concept of cards. So basically a pack is going to have total 52 cards. So we are going to split these cards into 4 categories, which are the spade, club, diamond and the heart. So spade, club, diamond and heart. So spade means each category is going to have total 13 cards. So 13 into 4 is nothing but 52. So therefore we can say we are going to divide this pack into 4 categories, which are spade, club, diamond and heart, and each category is going to contain 13 cards. Categories are spade, club, diamond and heart. So each set has cards, or we can say each set or each category is going to have cards which are 2, 3, 4, 5, 6, 7, 8, 9, 10, J, K, Q, A. Jack, King, Q and this A. So therefore we can say the cards which are going to there for each and every set, which are total 13. So you can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these are the 13 cards which are going to present in the each and every set, which are the 2, 3, 4, 5, 6, 7, 8, 9, 10, J, K, Q and A. So therefore here out of these black will be, see the black will be spade and club, both are going to have a black in color. So spade and club are both are in black color. So the total number of black cards are 13 plus 13, which is the 26 cards. Whereas the red category, means the red color will be both diamond and heart will be both red in color, and their total combination is 13 plus 13, which is 26 cards. So therefore we can say cards are total number of cards are 52. Out of this we are going to split into 4 categories, which are the spade, club, diamond and heart. So each set is going to have total 13 cards. The cards in each set are 2, 3, 4, 5, 6, 7, 8, 9, 10 and J, K, Q and A. So if you want to know the black colors of the cards, which are the combination of the spade and club, both are black in color. 13 plus 13 is 26 cards. Whereas if you want to know the red cards, which are the combination of the red, diamond and the heart, which are the 13 plus 13 is equal to 26 cards. So now we are going to learn about the conditional probability. See, the conditional probability is, suppose there is a sample space, yes. Out of the sample space means suppose I did some experiment. So the number of outcomes on that experiment is called as the sample space. So out of the sample space I am going to consider two events, A and B. Two events are A and B. Then the conditional probability is what is the probability of event A occurring already when the event B is already occurred. So listen carefully. The probability of A dash B means the probability of event A occur when event B is already occurred. Means the probability of event A occurring when the event B is already occurred, which is probability of A by B is equal to the probability of A intersection B by the probability of B. Means what is the probability of occurrence of both event A and B by the probability of event B. That is called as the probability of A dash B, or simply we can say what is the probability of event A occurring when the event B is already occurred. The condition is the probability of event is already occurred. Then what is the probability of occurrence of the probability of event A? That is the meaning of the probability of A dash B. Similarly, if you want to know what is the probability of event B occurring when the event A is already occurred, which is the same as the previous one, which is the probability of A intersection B by the probability of A. Means what is the probability of the occurrence of the A and B events by the probability of event A. So simply the probability of A dash B means what is the probability of event A happening if event B is already happened. Means this is a condition. If the event B is already happened, then what is the probability of occurring or happening of the event A. Similarly, the probability of B by A means the probability of event B happening if event A is already happened. This is a condition. With this we are going to understand these things. This is called as the probability of happening of both A and B, and here this is called as the probability of event B happening, and this is we are going to call as the probability of event A happening. If A and B are independent events, then means here independent events means both are independent means the occurrence of A is not going to affect the occurrence of B, or simply the occurrence of B is not going to affect the occurrence of A. That we are going to call it as the independent events. See, the meaning of independent events is this A is independent of event B and event B is independent of the event A. That we are going to call it as the independent events. Means the occurrence of one event is independent of the other event. Then we are going to call these events as said to be independent events. Then if this is a condition, then the probability of A intersection B is equal to the probability of A into probability of B. And similarly, the probability of A by B is equal to the probability of A, because already probability of B and probability are independent of each other. So therefore, the probability of A happening is independent of the probability B is happen or not. So therefore we can say it is equal to the probability of event A. And similarly, the probability of B by A is equal to again the probability of event B. So you can replace this one in the above formulas, and if you do the simplification, we are going to get in this manner. So simply one thing is very much clear. If A and B are independent events, means the occurrence of one event is independent of the other event, then definitely we can say the probability of intersection B is equal to the probability of A into probability of B, and the probability of event A happening when the event B is already happened is equal to the probability of event A only. And similarly, the probability of event B happening when the event A is already happened is equal to the probability of event B is equal to, because both are the independent events. So now we are going to learn about the statistics. The formulas of the statistics, which are the mean or arithmetic mean or the expectation. So one of the important concept of statistics is mean or arithmetic mean or the expectation. Everything is same. So we can either call it as a mean or arithmetic mean or expectation. So the different symbols are mean, we can write x bar or mu x or e of x. Everything is same. So therefore x bar is also called as a mean, or mu x is also called as a mean, or e of x is also called as mean. So mean or arithmetic mean or the expectation. X bar is equal to mu x is equal to e of x, which is equal to x bar is equal to summation of the each and every quantity by total number of quantities. So x1 plus x2 plus up to xn by total number of events are going to present here. The data is going to present, which is n. So therefore, or simply we can say sigma xi into fi by sigma fi, means fi is nothing but the frequency, the number of times this quantity xi is going to happen. Then you have to go for each and every data, and then you have to go like this division. So whether you go for in this format and this format, both are same. And it is also equal to sigma xi into wi. Means wi is nothing but here how much percentage of happening of the xi. So all these things which are same. So therefore simply we can say we can go any of this format to get the arithmetic mean or the expectation, which is the x bar is equal to x1 plus x2 plus up to xn by n, or sigma xi into fi by sigma fi, or simply we can say sigma xi into wi. So no matter whatever the things you are going to get, you are going to get the same result. So now we are going to learn about the median. So now up to now we studied about the mean. So now we are going to learn about the median. See, always arrange the numbers in the ascending order. See, whatever the data which is going to present to you, we have to arrange in the increasing order, or you can say ascending order from small to big. Let me assume this is the data that you arranged in the increasing order or the ascending order. Then if n is equal to odd, means if odd numbers are going to present, means if you have a set of data, the number of data which are going to present in the set, if it is odd, then median is equal to t of n plus 1 by 2. Then you are going to get n, the total number of data plus 1 by 2. If you do this one, the term is said to be a median. So suppose if you are going to have even number of things, if you are going to have even number of data present in a set, then median is equal to average of t of n by 2 plus t of n by 2 plus 1. So you have to go for the average of these two terms to get the actual median. So therefore, sometimes median can be present in the data, sometimes median cannot be present in the data. That is the meaning of this one. So therefore, simply we can say if n is the odd number, then the median term is equal to t of n plus 1 by 2. If suppose it is an even number, then it is the average of the t of n by 2, comma t of n by 2 plus 1. So like this we have to go for the average to get the actual median. So sometimes median can be present in the set of the given data, and sometimes it may not be even present in the given set of data. Mode. Now we are going to learn about the mode, which is the value which repeats more number of times is called as the mode. So it can be more than 1. So therefore the value which repeats more number of times is called as the mode. It can be more than 1 means, see, mode means suppose if you are going to have a set of data, in that some number will be repeating more number of times. That number we are going to call it as the mode, or simply here mode can be more than 1. It may not be a single number, it can be more than 1 depending on the set of data which is going to present in the set. So now we are going to learn some more important things, which are the sigma square. So sigma is called as the standard deviation, where sigma square we are going to call it as the variance. So sigma square is equal to sigma, this sigma square is equal to sigma xi minus x bar whole square by n. So therefore sigma xi minus x bar whole square by n we are going to call it as the variance. Or you can write in another format, If you want to know only the sigma, sigma is equal to under root over sigma xi minus x bar whole square by n. Or we can write this one in another format also, which is under root over n into sigma xi whole square minus sigma xi whole square by n square. So either you go for this process or either you go for this process, still you are going to get the same result, which is n into sigma of xi square minus sigma xi whole square by n square under root. Or either you can go in this process or this process, still you are going to get the same thing. So sigma square is equal to expectation of x square minus expectation of x whole square. So it's a very important formula. So sigma square is equal to expectation of x square minus expectation of x whole square. See, expectation of x whole square, you can write mu of x square minus mu of x whole square. So now here, what is the mean of this one? See, expectation of x square means you have to go for the summation sigma xi whole square by n minus sigma of xi by n whole square. So if you do the simplification, still we are going to get the same above result. This result we are going to get. We can compare these two equations. If you take n square as LCM, you are going to get here n into sigma xi square minus sigma xi whole square by n square you are going to get. So therefore same thing as this one. So whether you can go in this method or in this method, everything is same. So therefore sigma square is equal to expectation of x whole square minus expectation of x whole square. So therefore we can say simply sigma xi square by n minus sigma xi by n whole square. If we do simplification, we are going to get this one. Where sigma is called as the standard deviation, or simply we are going to call it as the root mean square, whereas sigma square we are going to call it as the variance. Sigma means standard deviation or the root mean square, or sigma square means variance. So definitely sigma square is equal to expectation of x square minus expectation of x whole square. Expectation of x square means sigma xi square by n minus sigma xi by n whole square. Simply we can say variance is equal to expectation of x square minus expectation of x whole square. Suppose if you want to figure out the standard deviation for the group data, then how to figure out this one? Suppose I am going to assume capital N is equal to sigma fi, means I have already told you fi means the number of times the data is going to get repeat. So therefore just you have to go for the summation of each and every data which is going to repeat how many number of times. And x bar is equal to sigma fi into xi by total n, or n is equal to sigma fi. You can write any of these things. So then I have already told you the standard deviation is equal to under root over sigma fi xi square by capital N minus sigma x bar whole square. So now you can replace x bar is equal to sigma fi xi by n, and then if you take the LCM of n square, you are going to get under root over n into sigma fi xi square minus sigma fi xi whole square by n square. So you can just replace this formula by this one, and if you do the simplification, we are going to get this value. This we are going to call it as the expectation of x square. This is called as the expectation of x square minus expectation of x whole square. So we have replaced this one by the previous formula, and do the simplification, we are going to get this value. So now we are going to learn about the coefficient of variation. So coefficient of variation, simply we are going to call it as the CV. So CV we are going to call it as the coefficient of variation. It is a ratio of the sigma by mu. Coefficient of variation means it is a ratio of the sigma by mu, where sigma is called as the standard deviation of the data set, and mu we are going to call it as the mean of the data set. So sigma is nothing but it is a standard deviation of the data set, and mu we are going to call it as the mean of the data set. It is just the ratio of the standard deviation of the data set by the mean of the data set. So if you want to know what is the percentage CV, just you have to go for the multiplication of the 100. You are going to get the percentage of the coefficient of the variation. It is the ratio of the sigma by mu. Sigma is called as the standard deviation of the data set, whereas mu is called as the mean of the data set. So important point to note here, the data set with more percentage CV is more dispersed. Means if the CV is more, means the data is going to spread more and more further, wider. That is the meaning of the CV. The coefficient of variation means the data set with more percentage CV is more dispersed, means it is going to spread in a wide range of x-axis, that we are going to call it as the percentage of CV. So now we are going to figure out the median for the group data. How to figure out the median for the group data, which is first calculate the n plus 1 by 2, then find the median class, which has a cumulative frequency which is just equal or just more than the n plus 1 by 2. Then median is equal to L plus n plus 1 by 2 minus f plus 1 by fm into h. See, first thing is here, we have to calculate the n plus 1 by 2, then find the median class which has a cumulative frequency which is just equal or just more than the n plus 1 by 2. So whatever the data set we have, just go for this one n plus 1 by 2 and then try to figure out the cumulative frequency which is just equal or just more than the n plus 1 by 2. Then the median is equal to L plus n plus 1 by 2 minus capital F plus 1 by fm into h, where n is called the total number of data items, and f is called as the cumulative frequency of the class just above the median class, whereas fm is called as the frequency of the median class and h is called as the width of the median class and capital is called as the lower limit of the median class. So therefore here the only way to figure out the median is equal to L plus n plus 1 by 2 minus f plus 1 by fm into h, where n is called as the total number of data items, whereas capital F is called as the cumulative frequency of the class just above the median class, whereas fm is called as the frequency of the median class, whereas h is called as the width of the median class, whereas capital L is called as the lower limit of the median class. So if we substitute each and everything, we are going to get the median for a group data. Now we are going to discuss about the mode for the group data, how to figure out the mode for a group data. See, identify the class which has the largest frequency, means whichever the class of data is going to have highest frequency, first we need to figure out. So now that class is called as the model class. So that class we are going to call it as the model class, means the class with the largest frequency, that we are going to call it as the model class. So now calculate the mode, which is mode is equal to L plus f0 minus fm by 2 f0 minus f1 minus f2 into h. So f0 is called as the largest frequency or frequency of the model class, whereas f1 we are going to call as the frequency in the class just above the model class, whereas f2 frequency in the class just below the model class, whereas h is called as the width of the model class, and whereas capital L is called as the lower limit of the model class. So these are the things that you need to remember. So therefore, see, mostly the questions won't be asked in the group data, but as a formality I am going to discuss these important things also. So therefore, here the mode is equal to L plus f0 minus f1 by 2 f0 minus f1 minus f2 into h. See, always out of group data we have to figure out the class with the more number of frequency, that we are going to call it as the model class, whereas f0 we are going to call as the largest frequency or the frequency of the model class, whereas f1 is called as the frequency in the class just above the model class, whereas f2 is called as the frequency in the class just below the model class, whereas h is called as the width of the model class, whereas capital we are going to call as the lower limit of the model class. Now we are going to discuss about the approximate formula which is relating the mean, median and the mode, which are the mode is equal to 3 times of median minus 2 times of mean. See, always mode is equal to 3 times of median minus 2 times of the mean. So the simple way to remember is here, this is of NE and NE. So therefore it is going to have more number of letters when compared to mean. So therefore we can say this is 3 and this is 2 minus this is simple. So therefore we can say simply mode is equal to 3 times of median minus 2 times of mean. So therefore mode is equal to 3 times of median minus 2 times of mean. Definitely questions are already been asked in this formula. So now we are going to discuss about the frequency distributions. There are 3 types of frequency distributions, which are the positively skewed distribution, symmetric distribution, and also negatively skewed distribution. So these are the 3 types of frequency distributions, which are the positively skewed distribution, symmetric distribution, and the negatively skewed distribution. So now we are going to learn about this positively skewed, symmetric distribution, and the negatively skewed distribution. Suppose if the graph in this manner, so you can see clearly the peak is going to come closer, so therefore this we are going to call it as the positively skewed distribution. Then we can say this is in this positively skewed distribution, always mode is always less than or equal to median is always less than or equal to mean. This is the relation between the mean, mode, median, and the mean in the positively skewed distribution. If the data is going to distribute in this manner, then we are going to call it as the symmetric distribution. Then in this symmetric distribution, always mean, median, and the mode are always going to equal. So this is the meaning of the symmetric distribution. But in the negatively skewed distribution, the data is going to more maximum at this range of frequencies. Then we are going to call it as the negatively skewed distribution. In this, the mean is always less than or equal to, median is always less than or equal to mode. So you can see clearly here, it is a median, it is a median. Just this mean and mode are going to interchange both their places. So therefore, mean is less than or equal to mean is less than or equal to mode. So only these two quantities are going to get interchanged between the places between the positively skewed and the negatively skewed distribution, but the symmetric everything is same. So therefore, if you remember this one, then you can easily go for this one. So therefore, mode is always less than or equal to median is always less than or equal to mean for a positive skewed, but symmetric everything is equal. If you are going to ask for negatively skewed distribution, just interchange these two things. So now we are going to discuss about the binomial distribution. The binomial distribution is the probability of x is equal to r is equal to NCR into probability p to the power of r into 1 minus p to the power of n minus r. Suppose there are, there n indicates the number of trials, r indicates the number of times this event happening, whereas p is called as the probability of this event is happening. So therefore, simply we can say here, I want to know what is the probability of event, the probability of the number of times this event is going to occur. See how many number of times this event is going to occur, I want to figure out. So probability of x is equal to r is equal to NCR into p to the power of r into 1 minus p to the power of n minus r, means this many number of times the probability is going to occur and this many number of times this event is not going to get occur. So therefore we can say here NCR into p to the power of r into 1 minus p to the power of n minus r. So this many number of times it is going to get occur. This we are going to call it as the binomial distribution, where n is called as the number of trials. The number of trials, where r is the number of times this event is going to get occur out of n. So n minus r means the number of times this event is not going to get occur. Where p is called as the probability of this event happening, whereas 1 minus p is called as the probability of this event is not going to get occur. So therefore, simply the probability of the event, out of n trials, the number of times this event is going to occur r times I want to figure out, which is equal to NCR into p to the power of r into 1 minus p to the power of n minus r. So therefore, if you want to know what is the expectation of this binomial distribution, then the expectation of this binomial distribution is equal to n into p. Is the total number of trials into the probability of success. The probability of event is going to get occur. So therefore, n into p. But if you want to know what is the variance of this binomial distribution, which is np into 1 minus p, or we can say simply np is 1 minus p, sometimes they are going to replace by q. So therefore, np q, or sometimes you can go for both np into 1 minus p. You can choose anything. In both the ways you are going to get the same result. So therefore, the expectation of the binomial distribution is equal to n into p, whereas the variance of this binomial distribution is equal to np into 1 minus p. So therefore, we can say that n is called as the total number of trials, where r is called as the number of times this event is going to get occur out of n trials, whereas p is called as the probability of this event is going to get occur. Binomial distribution, which is the probability of x is equal to r is equal to NCR into p to the power of r into 1 minus p to the power of n minus r. So if you want to know what is the recurrence relation, which is probability of r is equal to NCR into p to the power of r into 1 minus p to the power of n minus r. So now I want to go for replace r by r plus 1. Then wherever r is there, just replace r plus 1. Then you are going to get this relation. So now what we are going to do is, now we are going to do the division of these two things, and finally you are going to get a relation in this manner, which is the probability of r plus 1 is going to depend upon the probability of r. So therefore this is called as a recurrence relation, means this present value is going to depend upon the past value. That is the meaning of the recurrence relation. So then the binomial distribution, the important formula is the probability of r is equal to NCR into p to the power of r into 1 minus p to the power of n minus r, where n is called the total number of trials. So out of these trials, r number of times this event is going to get occur, and the p is called the probability of event occurring, and 1 minus p means the number of times, means the probability of this event is not going to get occur. And if you want to know what is the expectation of this binomial distribution, which is equal to n into p, whereas the variation of the binomial distribution is equal to np into 1 minus p. So now we are going to learn about the geometric distribution. Geometric distribution, which is the experiment is done till we get success, after that stop. See, the meaning of this one is we have to do the experiment till we get success. After that, we have to go for the stop. So therefore, simply we can say that, see, we have to do the process, we have to do the experiment till we are going to get the success. See, whenever you got the success, just you have to stop that experiment. That is the meaning of the geometric distribution. Suppose in the initial case, in the first step only, suppose I got the success, then you have to go for the stopping for the remaining process. Or simply we can say that R is equal to 1, means only one time is going to get occur, and the probability of the P is called the probability of the success. Suppose if you are going for the first step, you are going to get fail. Suppose if you got the success in the second step, then the probability of failure is nothing but 1 minus P plus the probability of success is P, means total number of steps are 2, R is equal to 2. Suppose if you are going to go for the R is equal to 3, means first initial 2 stages we are going to get failure, then only we are going to get the success in the third stage. For failure, the probability of failure is equal to 1 minus P, but we are going for 2 times, which is 1 minus P into 1 minus P is 1 minus P whole square. But there is a success probability is P, so you have to go for the multiplication of each and every thing. And similarly, if you are going for 4 number of times, means for 3 times we are going to get failure, but the 4th time we are going to get success. The probability of failure is 1 minus P, but the number of failures is 3, so therefore 1 minus P whole cube into, but the probability of success is P, so therefore you have to go for 1 minus P whole cube into P. Suppose if you are going for the 5 number of steps, means for the 4 times we are going to get failure, and 5th time we are going to get success. So therefore simply we can say 1 minus P whole to the power of 4 into P. So therefore the probability of X is equal to R is equal to 1 minus P whole to the power of R minus 1 into P, means for R minus 1 times we are going to get the failure, only for the last time we are going to get the success, means R minus 1 are the failure, only 1, this power of P is 1, so this is called as a success. So this is called as the geometric distribution, means we have to do the experiment till we are going to get the success. So whenever we got the success, we have to stop the process. If you want to know what is the expectation of the X in this geometric distribution, which is 1 by P, whereas variation of this X in this geometric distribution is 1 minus P by P square. So therefore this is a very important thing here. So expectation of X is equal to 1 minus P, whereas variation of X is equal to 1 minus P by P square, 1 minus P by P square. So simply the expectation of X is equal to 1 minus P, whereas the variation of X is equal to 1 minus P by P square. So suppose if probability of X greater than R, if probability of X greater than R, it indicates that. If probability of X greater than R indicates that, means we have to get success only after R number of steps. Only after R number of steps, means here we can get R plus 1, R plus 2, R plus 3, like that. So therefore if you do, this is nothing but an infinite sum series. This is called as the infinite num series. If you go for the geometric mean or the geometric simplification, the summation of infinite number of geometric sum, the formula is A by 1 minus R. If you do the simplification, we are going to get 1 minus P over to the power of R, means after R only we must get the success, means at R plus 1, R plus 2, R plus 3, like that. So if you go for each and everything, the summation is the geometric mean, so therefore it is A by 1 minus R, initial value by 1 minus R, R is the ratio. If you do simplification, we are going to get 1 minus P over to the power of R, we are going to get for probability of X greater than R. So the expectation of X in the geometric distribution is 1 by P, whereas variation of X in the geometric distribution is 1 minus P by P square. So now we are going to learn about the hypergeometric distribution. Hypergeometric distribution. Suppose there is a capital N. In this capital N, there are R number of data, so the remaining data will be N minus R. See, out of this capital N, I am going to pick a small n, means out of this total set N, I am going to choose another set of N. So out of this set N, suppose I am going to get X data similar to R set, whereas N minus X data similar to this set. So therefore now the probability of capital X is equal to X is equal to means what is the occurrence of the total X from this whole set, which is equal to RCX into N minus R C of N minus X by total NCN. Suppose you can see clearly out of this N set, let me assume this is a black and this is a white. Then I have chosen another set of this N, then how many number of these things are going to occur in this black, I want to figure out. So therefore probability of capital X is equal to small x is equal to RCX into N minus R C N minus X by NCN. So this we are going to get the hypergeometric distribution. If you want to know what is the expression of this X, if you want to know, which is the small n into R by capital. So small n into R by capital. It's a very important formula. So therefore the expression of small x is equal to here small n into r by capital N. So small n into r by capital N is the expression of this small x. So now we are going to learn about the correlation and the regression. See, the correlation and regression means suppose there is a data. So with the help of this data, we are going to draw some line between this data. So that is called as the correlation and regression. Suppose there are the points which are the x1, y1 and similarly x2, y2, and there are up to points which are the xn, yn. So therefore we can simply say that there are total n number of points. So now here, now I am going to find what is the mean of the x coordinates. So each and every x coordinate I am going to take the mean, which is x bar is equal to sigma xi by n. Similarly, I am going to take the mean of each and every y coordinate, which is y bar is equal to sigma yi by n. So now there is also another constant which is I am going to assume, which is r. R is equal to sigma xi x into y by n into sigma x into sigma y. So therefore sigma x into y by n into sigma x into sigma y. The capital X is equal to, this capital X is equal to xi minus x bar, whereas this capital Y is equal to yi minus y bar. So for each and every data we have to do this process and we have to go for the final amount of addition by n into sigma x into sigma y, where sigma x is called as the standard deviation of the x, whereas sigma y is called as the standard deviation of the y. So therefore always r is equal to sigma capital X into capital Y by n into sigma x into sigma y. So capital X is equal to xi minus x bar, and similarly capital Y is equal to yi minus y bar, whereas sigma x is equal to, it is called as the standard deviation of the x, which is equal to under root over exponential of x square minus exponential of x whole square. And similarly sigma y is equal to, standard deviation of the y coordinates is equal to under root over exponential of y square minus exponential of y whole square. So therefore here, if you want to know what is the value of r, we have to go for this process, which is sigma x into y by n into sigma x into sigma y. The capital X is equal to xi minus x bar, whereas capital Y is equal to yi minus y bar. And you have to go for each and every data, and then finally you have to go for the addition. But here n is called the total number of data points which are going to present in this set, whereas sigma x is called as the standard deviation of the x variable, which is equal to under root over exponential of x square minus exponential of x whole square. And similarly exponential of y is equal, or the standard deviation of y is equal to under root over exponential of y square minus exponential of y whole square. This r we are going to call it as coefficient of correlation. So this r we are going to call it as the coefficient of the correlation. So with the help of the points, these n number of data points, we are going to draw a straight line by joining all these points. That line we are going to call it as y is equal to x plus b, and also x is equal to cy plus d. So these two lines passes through x dash comma y dash, or we can say x bar comma y bar, means always see whether you go for y is equal to x plus b or x is equal to cy plus d. You can go for any of these lines, still these lines are going to pass through all this data, and also these lines are going to pass to the point which is called as the x bar comma y bar, or simply we can say x dash comma y dash. So this line is going to pass through the point which is x dash comma y dash or x bar comma y bar, which is called as the mean of the x coordinate and also mean of the y coordinate. So y is equal to x plus b. So now what I am going to do is, here now I am going to substitute this point x bar and y bar. So here y bar is equal to a x bar plus b. So therefore y bar is equal to sigma y by n is equal to a into sigma x by n plus b. So if you take the LCM as, if multiply by n on the both sides, we are going to get this equation, which is the sigma y is equal to a into sigma x plus n into b. This is the equation 1. Similarly, for suppose what I am going to do is, here now I am going to multiply by x for this coordinate and also this one. So therefore this will become sigma x into y is equal to a into sigma x square plus b into sigma x. So if you are going to multiply by x, it is going to come inside and it will become x square, and this will become here b into sigma x we are going to get. So this is the equation 2. So solving these two equations, we can get the value of a and b. So if you solve these two equations, now with the help of these two equations, we can figure out the value of the a and b constants. So if you take it inside x, and also x square, and this n you need to remember, you have to remove, so it will become b into sigma x. Suppose if the straight line y, x is equal to cy plus d, then what you have to do is, here if you want to know the value of c and d, this line is also going to pass through the x bar comma y bar. So substitute here x bar is equal to 3 y bar plus d, but x bar is equal to sigma x by n, whereas y bar is equal to sigma y by n. If you take n as a L, if you multiply by n on both sides, we are going to get sigma x is equal to 3 into sigma y plus n into d. Similarly here also, if you take y multiplication inside, it will become sigma x into y is equal to c into sigma y square plus d into sigma y. So you can see that there are two equations with two unknowns, c and d, and if you can solve this one, we can get the value of the c and d. So now these are the two equations which are the y is equal to x plus b and x is equal to cy plus d. So now what I am going to do is, I am going to, this line already I have told you, this line is going to pass through a point which are the x bar comma y bar, and it is going to have a slope which is r into sigma y by sigma x. So if you substitute here, we are going to get y minus y bar is equal to slope is equal to r into sigma y by sigma x into x minus x bar. Similarly, this line is also going to pass to the same point which is the x bar comma y bar, and it is going to have a slope which is r into sigma x by sigma y. So therefore, x minus x bar is equal to r into sigma x by sigma y into y minus y bar. So with the help of these things, now what we are going to do is, now we are going to multiply the slope of this line and also slope of this line. So we are going to get r into sigma y by sigma x into r into sigma x by sigma y. So sigma y cancels, sigma x cancels. So we are going to get finally which is equal to r square. So therefore now, if r square is equal to 1, then these two lines will coincide with each other. So if this is a condition, if r square is equal to 1, it indicates that these two lines are going to coincide with each other, means they are going to become same line. Otherwise, if r square is not equal to 1, then these two lines won't coincide with each other. So simply we can say, whenever r square is not equal to 1 means these two lines are not going to coincide with each other, but if it is equal to 1 means these lines are going to coincide with each other. That is the meaning of this correlation and the regression. We are going to learn about the random probability. Means the random probability means it is a discrete in nature. So with the help of this discrete in nature, what we are going to do is, suppose there is a sample space. So now because of the sample space, we are going to get, so we are going to do basically an experiment. So experiment is basically going to have lot of amount of outcomes. So we are going to call it as the sample space. So now what we are going to do is, for these outcomes we are going to assign some real number. So we are going to assign some real number for these outcomes. So then we are going to find the probability of this real number we are going to figure out. So therefore, simply suppose we are going to do some experiment. So experiment is basically going to have some outcomes. So from these outcomes we are going to assign some real numbers for these outcomes. Then out of these real numbers, means these real numbers we are going to find the probability for these real numbers we are going to figure out. That is meaning of the random probability or the discrete in nature. We are going to discuss some of the properties regarding this discrete probability, which is exponential of x is equal to sigma x into p of x. See, exponential of x is equal to sigma x into p of x. This is called as the exponential of x, which is equal to sigma x into p of x. Whereas the variance of x is equal to exponential of x square minus exponential of x whole square. It is also equal to sigma square. Where sigma is called as the standard deviation, whereas sigma square we are going to call it as the variance. And similarly, exponential of g of x is equal to sigma g of x into p of x. Or simply we can say replace x by g of x, we are going to get here sigma g of x into p of x. So therefore simply we are going to get in this format. So therefore exponential of g of x is equal to sigma g of x into p of x. Whereas the variance of the g of x is equal to exponential of g of x whole square minus exponential of g of x whole square. So x is called as a random variable. So we can go in this process or in this process we are going to get the same result. So therefore variance of g of x is equal to exponential of g of x square minus exponential of g of x whole square. So where always x is equal to random variable. Whereas exponential of x square is equal to sigma x square into p of x. So therefore, if you want to know what is the exponential of x square, just replace here x by x square. We are going to get exponential of x square is equal to sigma x square into p of x. Whereas exponential of x is equal to sigma x into p of x. Now the variance of x is equal to exponential of x square minus exponential of x whole square. Or simply we can say sigma x square into p of x minus sigma x into p of x whole square. So we can go for this, either you can go by this formula or this formula, we are going to get the same result. So therefore variance of x is equal to expectation of x square minus expectation of x whole square is equal to here sigma x square into p of x minus sigma x into p of x whole square. So we are going to get the same result. So if you want to know what is the expression of ax plus or minus b, where x is a random variable and a and b are the constants, it is equal to a into expression of x plus or minus b. So therefore a into expression of x plus or minus b. It's a very important formula because from this properties definitely there are already asked so many different questions. So therefore expression of ax plus or minus b is equal to a into expression of x plus or minus b. Whereas expression of ax plus or minus by is equal to a into expression of x plus or minus b into expression of y. Whereas variance of ax plus or minus b is equal to a square into variance of x. So for constant value the variance is equal to 0. That is the reason a square into variance of x. So variance of ax plus or minus b is always equal to a square into variance of x. Whereas variance of ax plus or minus by is equal to a square into variance of x plus b square into variance of b plus or minus 2ab into covariance of x comma y. It's a very important formula. So listen, variance of x plus or minus by is equal to a square into variance of x plus b square into variance of y plus or minus 2ab into covariance of the x comma y. The formula of the covariance of x comma y is equal to expression of x into y minus expression of x into expression of y. It's a very important formula, which is covariance of x comma y is equal to expression of x into y minus expression of x into expression of y. If x and y are independent, then only we can say the covariance of x comma y is equal to 0. So whenever x and y are independent events, then definitely expression of x into y is equal to expression of x into expression of y. Then these both are going to get cancelled. Then we are going to get answer as equal to 0. So therefore simply we can say if x and y are independent events, then definitely the covariance of x comma y is equal to 0 because expression of x into y is equal to expression of x into expression of y. So because of this reason we can simply say that the covariance of x comma y is equal to 0. Yes, the probability is always going to lie between 0 to 1 because the minimum value is 0 and the maximum value is 1. So it cannot be more than this one. Whereas sigma of p of x is always equal to 1 because if you do the addition of all the probabilities of an outcome, definitely it will be always equal to 1. So therefore sigma p of x is always equal to 1. And if you want to know what is the probability of x which is going to lie between a to d is equal to, means we have to go for each and every value from a to d, which is probability of x is equal to a plus, and it goes on up to the probability of x is equal to b. And see, if you want to know what is the expression of x plus b whole square, so if you do the expansion of x plus b whole square, we are going to get x square plus 2bx plus b square. So expression of x square plus 2b into expression of x plus we are going to get b square. So therefore expression of x square plus 2bx plus b square is equal to expression of x square plus 2b into expression of x plus b square. If you want to know what is the variance of ax plus or minus by plus or minus c, it is equal to a square into variance of x plus b square into variance of y, because for a constant term, whether it is a positive or negative, it's always we are going to get variance is equal to 0, and a plus or minus means it is always plus. We have to go for this one. So therefore a square into variance of x plus b square into variance of y. Whereas if you want to know what is the expansion of the, or we can say expression of x to the power of n is equal to sigma x to the power of n into p of x. So these are some of the important formulas of the discrete probability which is going to help you to solve the questions. Now we are going to learn about the continuous random probability. See, up to now we have discussed the random probability, means for discrete numbers. Suppose it is a continuous in nature, then how to figure out the probability we are going to discuss. For continuous random variable, suppose f of x we are going to plot as a probability density function, means it is a continuous in nature. Then always the integration of minus into infinity f of x dx is always equal to 1, means area under the graph should be always equal to 1. And we can say the overall probability should be always equal to 1. Therefore, the probability of a less than or equal to x less than or equal to b is equal to, means we have to go for the range from a to b, which is f of x into d of x. So therefore, if you want to know what is the probability it is going to lie between a to b is equal to, you have to go for the integration of a to b f of x into d of x, where f of x is going to be called as the probability density function. But if you want to know what is the probability of x which is less than or equal to b, means here we have to go from minus infinity to b f of x into dx. Means question they are asking only the probability up to b. So therefore integration minus infinity to b f of x into dx. But if you want to know what is the probability for x greater than or equal to a, means we have to go for integration from a to infinity f of x into dx. So by this we are going to get the overall area. The probability is the thing, but here how much is the area under the graph f of x dx. We are going to give you some range, so only up to that range we need to figure out. So expression of x is equal to integration minus infinity plus infinity x into f of x dx. This is for the, this formula is only for the continuous probability, whereas for the discrete net it is equal to sigma x into p of x. But for a continuous nature, expression of x is equal to integration minus infinity plus infinity x into f of x dx. If you want to know what is the expression of g of x, means here replace x by g of x, we are going to get this formula, which is integration minus infinity plus infinity g of x into f of x dx. But if you want to know what is the variance of x, is also called as a sigma square, which is expression of x square minus expression of x whole square. So expression of x whole square is nothing but here just replace x by x square. We are going to get integration minus infinity plus infinity x square into f of x dx minus. If you want to know what is the expression of x, substitute this formula, we are going to get minus infinity plus infinity x into f of x dx whole square. So by this we can also figure out the value of the variance of the x. Suppose if you want to know what is the probability which is going to lie between a to b, or also a to b, or see it can be either equal or less, we have to use the same formula. So therefore probability of a is not equal to b, or in any range same formula, which is a to b f of x into p of x. And similarly variance of g of x. See, variance of g of x is nothing but here I have already told you expression of x whole square minus expression of x whole square. So here in place of x replace g of x, we are going to get minus infinity plus infinity g of x whole square f of x into dx minus integration minus infinity plus infinity g of x into f of x dx whole square. Whereas expression of x to the power of n is equal to minus integration of minus infinity plus infinity x to the power of n into f of x dx. Always the probability density function at any value of x, it will be always equal to greater than or equal to 0. It cannot be any negative value. It will be always greater than or equal to 0. So now we are going to learn about the Poisson distribution. It's a very important concept, which is the probability of x is equal to the probability of occurrence of the x is equal to e to the power of minus lambda into lambda power of x by x factorial. It's a very important formula. The probability of x is equal to e to the power of minus lambda into lambda to the power of x by x factorial, which is e to the power of minus lambda into lambda to the power of x by x factorial. It's a very important formula because the probability of x is equal to e to the power of minus lambda into lambda to the power of x by x factorial. See, x can go from 0, 1 to up to infinity. See, this x is called as a random variable. It can be only a random variable, means only a purely integer value. And also here lambda is called as a lambda is equal to alpha into delta t, means where alpha is called as the average number of occurrence of event in due time, whereas lambda is called as the average number of occurrence of event in delta t duration. Means see how much amount of event is going to occur in a unit time. But in the question sometimes they are going to ask in a small amount of delta t, then what is the lambda? Lambda is equal to unit time into delta t. So therefore average number of occurrence of event in delta t duration. Whereas lambda is also called as the mean, or average is always positive, means its value is always greater than 0. So therefore simply lambda is also called as the mean or average, or it is always greater than 0. So therefore simply we can say how much amount of occurrence of the event in the delta t duration we need to figure out. It's also called as the mean or average, and its value is always greater than 0. So therefore always we can say the probability distribution, the probability of x is equal to the power of minus lambda into lambda to the power of x by x factorial. Here x is called as a random variable, and it's always going to go from 0, 1 to up to infinity. It's basically a random variable, whereas lambda is equal to alpha into delta t. Hence alpha is called as the average number of occurrence of event in unit time, whereas lambda is called as the average number of occurrence of event in delta t duration. The lambda is called as the mean or the average, and its value is always positive. Because x can go from 0 to infinity, therefore we can say the probability of x is equal to 0 plus up to infinity, its value is always equal to 1, because the probability of sample space is always equal to 1. So therefore if you do the addition of each and everything, always we are going to get the value of 1. Now what is the meaning of the first moment? The first moment is nothing but it is equal to lambda, and the second moment is equal to lambda plus lambda square. So the first moment is always equal to average value, so therefore, or mean value, whereas second moment is equal to lambda plus lambda square, whereas mean is equal to only in this case, only in this Poisson distribution, always mean and variance are both are same, which is equal to lambda. So only in the Poisson distribution we can say mean is equal to variance is equal to lambda. So therefore, if you want to know what is the standard deviation, because variance is equal to sigma square, so sigma is equal to under root over mean, so therefore we can say under root over lambda. So this is called as a standard deviation. So always variance and also expectation is always equal to lambda. But if you want to know what is the standard deviation, it is equal to under root over the lambda. So expectation of x is equal to variance of x is equal to lambda only in the case of the Poisson distribution. But if you want to know what is the first moment, it is equal to mean lambda. If you want to know what is the second moment, which is equal to lambda plus lambda square. You want to know the recurrence relation, which is p of x is equal to e to the power of minus lambda to the power of x by x factorial. See, now replace x by x plus 1, we are going to get this value, which is e to the power of minus lambda into lambda by x to the power of x plus 1 by x plus 1 factorial. And if you take the division, and if you can get this value, which is p of x plus 1 is equal to lambda by x plus 1 into p of x. So you can see the present value is going to depend upon the past value. So this we are going to call as a reconciliation. So only important formula which is in the Poisson distribution, which is p of x is equal to e to the power of minus lambda into lambda to the power of x by x factorial. Whereas lambda we are going to call it as the mean or the average, means the number of outcomes of an event which are going to apply in delta t duration that we need to figure out. So always mean is equal to variance in the Poisson distribution, which is equal to lambda, and also if you want to know what is standard deviation, which is equal to under root over the lambda. Now we are going to discuss about a uniform distribution. Means suppose there is a f of x probability density function. Suppose there are two variables a and b. So area should be always equal to 1, means if it will be always constant probability density function. If area is equal to 1 means if this length is b minus a, so b minus a, then this length should be always equal to reverse of this one, just 1 by b minus a, and only if you do the area, it will be equal to 1. So therefore we can say it is going to have a constant value from a to b with the height of 1 by b minus a. So therefore we can say the f of x is equal to 1 by b minus a only for this range, for a less than or equal to x less than or equal to b, but for the remaining range its value is equal to 0. Then only we can say the area of this probability density function is equal to 1. So for this one, the expression of x is equal to, means if you do the actual value of simplification for minus into plus into x into f of x, then we are going to get the value which is a plus b by 2. But similarly, we can find the variance of x, which is expression of x square minus expression of x whole square. If you do the total simplification, finally we are going to get a minus a whole square by 12. It's a very important formula. So expression of x is equal to a plus b by 2, whereas variance of x is equal to b minus a whole square by 12. So you want to know what is the expression of x to the power of n, which is integration minus into plus into x to the power of n into f of x into e of x. So but this function is defined only in the range of a to b. So remaining range it is always equal to 0. So therefore we have to go for integration a to b x to the power of n into f of x dx. So this whole thing is going to converge to this range. So always in the uniform distribution, the mean is equal to always, or you can say expression is equal to a plus b by 2, whereas variance is equal to b minus a whole square by 2. So now we are going to discuss about the univariate exponential distribution. Means here f of x is equal to lambda into e to the power of minus lambda x for x greater than 0 and is equal to 0 otherwise, means it is a decaying exponential for positive range of x. So therefore we can say if you do the integration of f of x from minus into plus into f of x dx, we are going to get area is equal to 1 for this function. So for this range, if you want to know what is the expectation of x is equal to here, 1 by lambda we are going to get. If you want to know what is the variance of the f for this function x, we are going to get finally 1 by lambda square we are going to get. So if you want to know what is the probability in this range, which is equal to integration of a to b, here f of x into dx, but f of x is nothing but here lambda into e to the power of minus lambda x into dx. So if you do the integration and if you substitute the limits, finally we are going to get e to the power of minus lambda a minus e to the power of minus lambda b. The lambda we are going to call it as the parameter. This is for the univariate exponential distribution. So now we are going to discuss about the last concept, which is the normal distribution. It's a very important formula, which is f of x is equal to 1 by root 2 pi sigma x into e to the power of minus x minus mu x by under root 2 sigma x whole square. So it's a very important formula for the range of minus infinity to plus infinity. So f of x is equal to 1 by under root over 2 pi into sigma x e to the power of minus x minus mu x by under root 2 into sigma x. You see how to remove pi, everything is same. So under root 2 into sigma x whole square. So for this function f of x, probability density function, is always greater than or equal to 0 for minus infinity plus infinity. So f of x is equal to 1 by under root over 2 pi into sigma x e to the power of minus x minus mu x whole square by under root 2 into sigma x whole square. Range of x range from minus infinity to infinity. So now exponential of x is equal to, it is always equal to this value mu x. So mu x is called as the mean or the exponential of x. But here if you want to know what is the variance of x, is equal to sigma x square. So whatever this value, if to the square, you are going to get the variance of the x, which is sigma x square. So therefore always this function is going to consider 2 points, which are the mu x and the sigma x. So if you know mu x, it is called as the exponential of the x. If you know sigma x, just do the square of this one, you are going to get the variance of the x. So if you draw this f of x with respect to x, we are going to get in this manner. So we are going to get in this manner. So therefore this peak value is going to lie at a value of x, is called as the mu x. Then here this range is called as this sigma, this division is called as a sigma x. So mu x plus sigma x, and this is mu x plus 2 sigma x. This is mu x minus sigma x, and this is also mu x minus 2 sigma x. Then we can say clearly for this range, for this total range, the area is going to consider 2%, and this is, if this is 2%, here also 2%. So this area, only this area is going to contain total 14%, only this area. Similarly here also this area is 14%, and similarly this area is again 34%, and this is also 34%. So easily to remember this 34%, 14%, and 2%. Same thing as a symmetrical one. So therefore 34%, 14%, and 2%. So therefore we can say this f of x normal distribution curve is going to have in this manner. So therefore 34%, 14%, and 2%. So this area is, the graph under this curve is for mu x plus sigma x is 34%, and this is 14%, and this is 2%. So if you do the integration from minus infinity to plus infinity, f of x into dx, this if you go for total area, it will be always equal to 1. But if you do only integration from minus infinity to mu x, means from minus infinity to mu x, if you do this one, this will be equal to 50%, or simply we can say 0.5. If this is 0.5, this is also 0.5. So for mu x minus 3 sigma x to mu x plus 3 sigma x, means from this range to this range, this will be mu x plus 3 sigma x, and this will be mu x minus 3 sigma x. If you do the overall area, we are going to get nearly 99%, means 0.9974. So therefore simply we can say it's an easy way to remember this one. So now we are going to do the standard curve. Means we are going to see, we are going to convert any normal distribution curve into standard curve with a mu value of sigma is, mu value means mu x is equal to 0 and sigma x is equal to 1. Means see, whatever the normal distribution curve, we are going, suppose it can have mu x non-zero value, it may have some non-zero value it can have. So what we are going to do is, we are going to simplify this one into a standard curve. The standard curve is going to have mu x is equal to 0 and sigma x is equal to 1. So therefore we can say simply mu x is equal to 0 and sigma x is equal to 1 for the standard curve. So we can convert any normal distribution curve into a standard curve by using this procedure, which is, it is going to have always mu x is equal to 0 and sigma x is equal to 1. So therefore simply we can say z is equal to x minus mu x by sigma x is equal to y minus mu y by sigma y. So this property is a very important property to way to convert. It is a way to convert anything, any normal distribution curve into a standard curve, which is the x minus mu x by sigma x is equal to y minus mu y by sigma y. So this is called as the mean value, and this we are going to call as the standard deviation. So therefore simply x minus mu x by sigma x is equal to y minus mu y by sigma y. So with the help of this, we can convert any data into a standard curve, which is going to have mu x is equal to 0, and the range of this value is equal to sigma x is equal to 1. So therefore 0, 1, again 1 plus 1 is again 2, again 3. So 0 minus 1 minus 2. So we are going to get mu x is equal to 0 and sigma x is equal to 1. Means if this is mu x, we are going to go for sigma x plus 1 is equal to 1. Again sigma x, we are going to get 2. Again sigma x, like this we have to go for this one. So I've already told this area is 34%, 14% and 2%. Same thing with respect to the symmetry also. So therefore, for the standard curve, always mu is equal to 0 and sigma is equal to 1. Or simply we can say mean is equal to 0 and the standard deviation is always equal to 1. This is the meaning for the standard deviation, or we can say this is the standard for the standard curve. This is standard curve, or we can say simply standard normal distribution curve with a mu is equal to 0 and sigma is equal to 1. So now we are going to learn some more important points. The probability, which is any activity which has outcomes or results, is said to be an experiment. Means if you are going to conduct any experiment, definitely we are going to get some amount of outcomes that if you combine all those things, we are going to call it as a sample space. So the collection of all outcomes from experiment, which is going to be denoted by S. So therefore, see, simply we are going to call it as a sample space. Means whatever the outcomes we are going to occur from an experiment, we are going to call it as, or we are going to define and set is called as the S, or simply we can say it is a sample space. Event is a subset of sample space. Means out of this total sample space, if you take any certain event, so simply we are going to call it as a subset of a sample space. Mutually exclusive events means here A and B, there is not even any relation, means they are not going to occur in a combined way. Means we can say simply that these two are never going to occur on a common basis. Means we can say these two events cannot occur at the same time. So therefore simply we are going to call it as the probability of A intersection B is equal to 0 whenever the two events are mutually exclusive events. Means these two things are not going to occur at the same time. They are going to be occurring at different times. So therefore we are going to call it as the mutually exclusive events. Means they are not going to occur at any same time. So therefore probability of A intersection B is equal to 0. See, exhaustive events means like this event 1, event 2 and event 3 means all going to occur. So therefore these never going to occur together. So similarly E1 and E3 they are not going to occur together, and not even any two events from the sample space are not going to occur together, but they are total are going to combine they are going to cover the total sample space. Yes, therefore probability of event, the probability of event E1 union E2 union E3 is always equal to 1. Means they are going to have event occurring E1 or E2 or E3 is always equal to 1. Independent event means the probability of A intersection B is equal to the probability of A into the probability of event B. See, there is no relation between the independent and also mutually exclusive. Means the probability of A intersection B is nothing but these two are independent of each other. So therefore probability of A intersection B is equal to the probability of event A into the probability of event B. Means the occurrence of one event cannot be depending on the other event. That is the meaning of the independence. So therefore probability of A intersection B is equal to the probability of A into probability of B. Suppose there is a Venn diagram with the sample space is, and these are the two events which are going to occur in the sample space. Then I want to know what is the probability of A union B. Means probability of occurrence of A or B, which is equal to the probability of A plus probability of B minus probability of A intersection B. It's a very basic formula. Means the probability of occurrence of event A or event B is equal to probability of event A plus probability of event B minus probability of A intersection B. See, always a leap year is nothing but it is going to contain 366 days. So but a normal year is going to contain only 365 days, but a leap year is going to contain one extra day that we are going to count, and definitely we are going to get 366 days. Means in a normal year February will have only 28 days, but in a leap year the February is going to contain one more extra day, just 29 days. So therefore simply we can say for leap year it will be 52 weeks plus 2 days. Means 52 weeks plus 2 days, if you add we are going to get 366. So therefore leap year is going to contain 52 weeks plus extra 2 days. Then we are going to get 366 days. Means February is going to contain 29 days. So elements are in arithmetic progression, then mean is equal to median. Suppose suppose there is a set of arithmetic means, we can say if whatever the data you are going to get, they are in arithmetic mean. So therefore if you are going to arrange in the increasing order, then if you do the mean median, they both are going to get equal. So mean and also median are equal only when the data, whatever the data, they are in arithmetic progression. Median is not affected by extreme values. See, always median is called as median is nothing but it is just if it is an odd integer, suppose if it is an even integer, which is the term of the n by 2, or we can say n by 2 comma n by 2 plus 1. If it is odd number, the term of the n plus 1 by 2. So we can say, whereas mean is going to affect by the extreme values, whereas the median is not going to get affected by the extreme values. I have already told you, sometimes median can be present in the data set, sometimes it may not be present. Standard deviation is more. It means the data is farly distributed. I have already told you the normal distribution, the distance between the ux and ux plus sigma x, that is called as the standard deviation. If sigma x is more, means the data is going to spread far and far. So therefore it is called as the, if the standard deviation is more, it means data is farly distributed, means it is going to distribute in a long range. Otherwise, if the standard deviation is less, means the data is closely distributed, means they are going to closely pack each other. Whereas if the SD is more, if the standard deviation is more, means the data is going to distribute in a widespread manner. Otherwise, it will be in a closely distributed. If each value of xi is plus or minus by k, then standard deviation does not changes. Means suppose the standard deviation is sigma, means if you are going to add each and every value, if you do either addition or subtraction by k, then the standard deviation is not going to get changed. If each value of xi is into or divided by k, then standard deviation into or divided by k and the variance into or divided by k square. So suppose if you go for addition or subtraction, the standard deviation and the variance are not going to get affected. But if you go for multiplication or division by k for every value of x, then standard deviation is going to go for the same factor, which is into or divided by k, whereas the variance we have to go for the same into or divided by k square. Then we have to just do the square of that one. If A, B, C are independent events, then what is the probability of occurrence of A intersection B when the event C is already happened? I have already told you, whenever everything is independent, definitely it is independent of event C, so therefore it will be equal to the probability of A intersection B, and A and B are independent events, so therefore probability of A into probability of event B. This I have already told you in the conditional probability concept. And the probability of P and Q is equal to probability of P plus probability of Q minus probability of P intersection Q. This concept I have already told you. So therefore, so from this we can see simply that these two are the addition and this we are going to subtraction. So from this we can clearly say that the probability of P and Q is always less than or equal to probability of P plus probability of Q, because we are going to the subtraction. So because of this only, this relation is going to get satisfied. So now we are going to learn some more important facts, which is the measure of skewness is independent upon the amount of dispersion. Means here the amount of skewness is dependent upon the amount of the dispersion. It's a very important point, which is the measure of skewness is dependent upon the amount of dispersion. In a symmetric distribution, the values of mean, median and the mode are always same. I have already told you what is a positively skewed distribution, symmetric distribution, and also negatively skewed distribution. In a positively skewed distribution, always mean is greater than median is greater than mode. Whereas in symmetric distribution, everything is equal. Whereas in negatively skewed distribution, just we have to interchange these last two elements. We are going to get this value, which is mode is greater than median is greater than mean. This also I wanted to told you in the previous one. If f of x is the continuous probability density function of a random variable x, then I have already told you the probability of A to B, whether it can be anywhere, it can be less or equal to any range, definitely it will be equal to integration A to B f of x into dx. Means we are going to find what is the probability of the function in the range from A to B, which is equal to integration of A to B f of x into dx. So you can see clearly this is 1 by root 2 pi sigma integration is equal to minus into plus infinity media power of minus x minus mu x whole square by, this is root 2 into sigma whole square. This is nothing but, this is called as the normal distribution. This is called as the normal distribution. If you do the integration from minus to plus infinity for normal distribution, we are going to get area is equal to 1. If suppose mu is equal to 0, what is going to happen? If you are going to substitute mu is equal to 0, then this will become minus x square by 2 sigma square. This will be, it is nothing but it is a symmetrical with respect to x axis. So therefore, instead of going from minus to plus infinity, we can go from 0 to infinity into 2 times is equal to 1. Suppose 2 fair dice are rolled and the sum r of the number turned up is considered now. See, now you are going to see some of the important points here. 2 fair dice are rolled and the sum R of the numbers turned up is considered null. What is going to happen? See, 2 fair dice means basically each fair will have 6 faces. So 2 fair means 6 into 6, 36 outcomes we are going to get. Suppose the probability of R by 3 is pure and integer, means the sum is R is equal to sum of the two integers plus R by 3 should be an integer. When R is equal to 3, 3 by 3 is 1. When R is equal to 6, 6 by 3 is again 2. Whereas when R is equal to 9, 9 by 3 is again, we are going to get integer 3. When R is equal to 12, 12 by 3 is again 4. But the sum can maximum up to 12 only, it cannot be more than that. So therefore you have to go for addition of probability of R is equal to 3 plus probability of R is equal to 6 and probability of R is equal to 9 and probability of R is equal to 12. So we have to get each and everything and do addition. We are going to get the probability of this one. But if you want to know what is the probability of R by 4 is an integer, whenever R is equal to 4, 4 by 4 is 1, again we are going to get integer. And when R is equal to 8, 8 by 4 is again 2, we are going to get integer. And similarly when R is equal to 2 also, 12 by 4 is again 3, we are going to get integer. So only this case, because more than 12 it cannot be occurred, so therefore probability of R is equal to 4 plus probability of R is equal to 8 plus probability of R is equal to 12, all these things if you do the combination sum, we are going to get this value. Similarly, the probability of R is equal to 8 and R is equal and R by 4 is an integer. See, I want to satisfy these both conditions. I want to satisfy both these conditions. See, R by 4 is, these are the combination and R is equal to 8. These are both are going to occur only for one common case, which is the probability of R is equal to 8. Means, see, R by 4 has a probability of R is equal to 8 and similarly R is equal to 8 is also there. So these two are going to occur only one common case, which is the probability of R is equal to 8. Similarly, probability of R is equal to 8 when R by 4 is an integer. See, probability of A by B is equal to probability of A into probability of B by probability of B. So therefore, probability of R is equal to 8 and R by 4 is an integer by probability of R by 4 is an integer. This thing already we have known with this value, and probability of R by 4 is also integer. This also we know. Just do the simplification and we are going to get the result. This is by the use of the conditional probability concept. If f of x is a probable density function defined in some region around x, which is, I have already told you, for a probable density function, then the overall area should be always equal to 1. So therefore integration of x is equal to minus 50 plus 50, f of x into dx is equal to 1. Then the mean value is equal to, already I told you, exponential of x is equal to integration x is equal to minus 50 plus 50 x into f of x dx. If you want to know what is the variance, it is nothing but sigma square is equal to exponential of x square minus exponential of x whole square, which is integration minus into plus into x square into f of x dx minus integration of minus into plus into x into f of dx whole square. And similarly, if you want to know what is the standard deviation, it is the under root over variance. It is equal to sigma. Sigma is called as the standard deviation, and if standard deviation is more, means the data is widely spread. If it is less, means the data is closely mapped. We are going to call x as the random variable. See, x is called as a random variable. Mean is nothing but mean of the random variable. Variance means variance of the random variable. Standard deviation means standard deviation of the random variable. All these things are indicates for random variable we are going to do, which is x is called the random variable, mean of the random variable, variance of the random variable, and also the standard deviation of the random variable. So now we are going to discuss about the probability of utmost one value. Means utmost means maximum one value. Therefore we can say the probability of x less than or equal to 1 means the probability of x is equal to 0 plus probability of x is equal to 1 means at most one value means up to one value only we have to go. So therefore x less than or equal to 1 means random variable will be always a 0 to infinity. So therefore we can say simply probability of x is equal to 0 plus probability of x is equal to 1. Suppose the cumulative distribution function f of x is the probability up to x. Means cumulative means we have to go for the addition up to the value of x. Suppose let me take a small example, which is x p of x. For minus 1 the probability is 0.5 and for plus 1 the probability is 0.5. So now what we are going to do is here, then now we are going to for the cumulative probability, which is capital F of x, capital F of x. So minus 1 means again 0.5. But for plus 1 the previous value is 0.5 and the present value is 0.5. So if we do addition we are going to get 1. So this we are going to call as a cumulative distribution function f of x is the probability up to the value of x. So up to the value of x we have to go for the addition of that one, that we are going to call it as the cumulative distribution function capital F of x is the probability up to small x. So let me take a small example here. Suppose there are 10 balls. Out of these 4 balls are red and 6 balls are black. So out of these 10 balls I want to remove only 3 balls. So these 3 balls, Suppose from these 3 balls I want 1 red ball and 2 black ball. So how many number of ways I can make this possible, which is the probability of 1 red and 2 red balls is equal to, see, 4C1 into 6C2 by 10C3. So this is called as a hyper geometric distribution. So like this we are going to do that way, which in this we are going to get the probability of 1 red ball and 2 black balls. So let me tell a small example, which is, suppose mu is equal to 1000 millimeter and the standard deviation is equal to 200 millimeter. Then what is the probability for x greater than 200 millimeter I want to figure out, which is equal to same. Now we are going to convert this into the standard curve, which is the z greater than x minus mu by sigma x. Therefore x's value is here 1200 minus x minus mu x, which is 1000 by sigma is 200. So if we do simplification, we are going to get, which is nothing but here, we are going to get 1. So z greater than 1. I have already told you for z greater than 1 is nothing but here, which is 14% plus 2%, or simply we can say 0.14 plus 0.02. So if we are going to get 0.1, nothing but 16% we are going to get. So therefore for this one, for this curve, mu is equal to 0 and sigma is equal to 1 for the standard curve always. Suppose there is a Poisson distribution. In the question they are given like this, lambda is called as a mean is equal to 3 cars in a minute. See, 3 cars are going to travel on an average basis, which are in a minute 3 cars are going to pass. Then on a bridge, then what is going to happen for probability x less than or equal to means less than 3 cars? What is the probability for less than or equal to 3 cars are going to pass, which is probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3. So you have the coefficient of each and everything, then only you are going to get the result, which is the probability of x is equal to e to the power of minus lambda into lambda to the power of x by x factor. This is the formula in the Poisson distribution. The lambda is equal as the mean or average on the basis of for amount of small time, how much number of things are going to pass. Suppose there is a capital f of x is equal to 1 by 1 plus e to the power of minus 1.7255 xn of mod of xn e to the power of 0.12. This is called as the standard cumulative probability function, probability from minus infinity to that value of xn. The xn is called as the standard normal deviation. Let the question they are given, let mu is equal to 1 or 2 centimeter is mean and the standard deviation is equal to 27 centimeter. Then the question they are asking, what is the probability from 90 to 1 or 2, the question they are asking. So now we are going to convert into a standard curve, which is x minus mu x by sigma x, which is 90 minus 1 or 2 by 27. From xn less than or equal to same here also x minus mu x by sigma x, which is 1 or 2 minus 1 or 2 by 27. So if you solve this one, we are going to get minus 0.44 less than x less than 0. So if you draw the graph of the standard curve, then we have to find what is the area between minus 0.44 to 0. But this we are going to get the area. This we are going to get the area up to the value of the xn. Simply we can say probability up to minus 150 xn. So now I want to make this area. Therefore, we have to go for total area minus this area. Then only we are going to get this value. So therefore, replace f of 0 minus f of minus 0.44 in this function, in this equation. Then we are going to get the value of the area for this one. Or simply we can say the probability of occurrence from minus 0.44 to 0. We are going to get the result. So this f of x is nothing but it is a probability from minus infinity to that particular point. Suppose there is a data x. So x is going to contain x1, x2 up to xn. Similarly, y is going to contain data from y1, y2 up to yn. Then mu x is called as the mean of this set, and sigma x is called as the standard deviation of this set. Similarly, mu y is called as the mean of this set, and sigma y is called as the standard deviation of this set. Then I want to correlate these two things, which is yi is equal to axi plus b. Suppose this is the equation which is going to correlate these two values, which is yi is equal to axi plus b. Then we can say the standard deviation of y is equal to mod a into standard deviation of x. So the standard deviation of y is equal to mod a into the standard deviation of x. And if you want to know what is the expectation of y is equal to a into expectation of x plus b, or you can say mu of y is equal to a into mu of x plus b. Index position of mode of x in x is the same as the index position of mode of y in y. It's a very important point, which is index position of mode of x in x is the same as the index position of mode of y in y, and similarly index position of median of x in x is the same as the index position of median of y in y. This is also very important point. And I have already told you variance of x is equal to sigma x square is equal to exponential of x square minus exponential of x whole square. So this value is always greater than or equal to 0. This variance value is always greater than or equal to 0. Is always greater than or equal to 0. So the probability of x less than or equal to 3 means the probability of observing fewer than 3 cards during any minute in this interval. See, in the Poisson distribution I already told you, the probability of x less than or equal to 3 means the probability of observing fewer than 3 cards during any given minute in this interval. Suppose x is equal to normal random variable. Then for this normal random variable, let me assume here the question they are given like this: mu is equal to 1, sigma square is equal to 4. So therefore, if this simplification we are going to get sigma is equal to 2. The question they are asking, suppose the probability of x less than 0, what is this value we need to figure out? So now we are going to convert this into a standard curve, which is probability of x less than 0 means probability of z less than here x minus mu x by sigma x, where x is 0, 0 minus mu is 1 by sigma is 2. So therefore we are going to get minus 1 by 2. So z less than minus 1 by 2 we are going to get now. So for minus of what is the probability? As I have already told you, for 0 means for 0 to minus infinity, for minus infinity to 0 the area will be 0.5. What is minus of means? From minus infinity to minus 1 means it will be less than 0.5. So therefore it is going to lie between 0 to 0.5. It is going to get lie. Suppose x is a normal random variable. For this, mu is equal to 600 and sigma is equal to 50. So mu is equal to basically 600 and sigma is equal to 50. Then what is the probability for x greater than 500 means we are going to convert into standard curve, which is z greater than x minus mu x by sigma, where x is equal to 500 minus mu is nothing but mu by sigma. So if you do a simplification, this is nothing but 500. So 500 minus 500 is again 0. So therefore finally we are going to get z greater than 0. So for probability of z greater than 0 is nothing but it's a 0.5. Probability of fourth head appeared at 10th toss is. So there is a small question here. Suppose what is the probability of fourth head? What is the probability of fourth head appeared at the 10th toss is? Means see, there are total 10 tosses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there will be fourth head at the 10th toss. Means in the remaining 9 cases, definitely there has to be 3 heads. Then only this will become fourth head. So the remaining, so out of total 9, 3 are heads. So remaining 6 must be tails. So therefore 3 heads and 6 tails. So basically this is the unbiased curve, means the probability of occurrence of it is equal to the probability of occurrence of tail. Then what is the net probability we need to figure out? So therefore simply we can say out of this 9 there will be 3 heads. So 9c3 into half of cube into half of the power of 6 into half. So simply we can say out of this 9c3 into this will be probability of it is half for total cube 3, and similar the probability of tail is half for 6. So 1 by 2 to the power of 6 into again 1 by 2. So this is also one more way. The another way is total number of ways. The total number of ways we are going to get is this out of 10. The total number of ways we can get is 2 to the power of 10 ways, because each task is going to have 2 outcomes. So 2 to the power of 10 outcomes. So out of this I want 9 heads. So I want only 9 heads. So therefore 9c out of 9 cases I want only 3 heads. So 9c3 by 2 to the power of 10 I am going to get the result. Suppose there is a small example which is here. Some parcels from sender S to receiver are parcels sequentially through 2 post offices. Post office has a probability of 1 by 5 of losing an incoming parcel, independently of all other parcels. Given that a parcel is lost, the probability that it was lost by the second post office is. So basically there are 2 post offices, 1 and 2. Suppose there is a probability of 1 by 5 is losing. 1 by 5 is equal to losing by the first parcel, or by the first post office. Or if it is gained, it is taken by the first post office, which is 1 by 5. Suppose it went to post office 1, but at the second post office it is lost, the probability of 1 by 5. In the question they are asking what is that the given parcel is lost, the probability that it was lost by the second post office is. That is the second post office, means this one. What is the probability of lost by the second post office, which is 4 by 5 into 1 by 5 by total 4 by 5 into 1 by 5 by 1 by 5. So the total probability of losing is either 1 by 5 or 4 by 5 into 1 by 5. But out of this only I want only this thing, which is 4 by 5 into 1 by 5. And then only I can get the overall probability which is lost by the going to loss by the post office to when the parcel is already lost. See a question here. Parcels from sender S to receiver are parcels sequentially grouped to post offices, and each post office has a probability of 1/5 of losing an incoming parcel, independently of the another parcels. When that the parcel is lost, probability that it was lost by the second post office is, means it is going to last, but it is already lost. We have to find what is the probability if it is lost by the second post office, means this probability by overall loss. We are going to get the actual result. One more small example, which is 4 fair 6-sided dice are rolled. 4 fair 6-sided dice are rolled. The probability that the sum of the results being 22 is x by 1296. What is the value of x is? So basically here there are 4 6-sided dice are rolled. The probability that the sum of the results being 22 is x by 1296. What is the value of x? Means if you do the summation of the numbers on the each side, when you are going to roll these 4 6-sided dice, then you are going to get this is the probability. So what is the value of x? We need to figure out of 22 sum. So 22 we can get in this phase, which is 6 6 6 4. 6 6 is 18 plus 4 22. Simply we can say 6 6 5 5. Only in this format only we can get the value of 22. The number of ways we can arrange this data is 4 factorial by 3 factorial into 1 factorial, which is nothing but 4 ways. The number of ways we can arrange this factorial is 1 2 3 4 4 factorial by 2 factorial into 2 factorial. So 6 ways. So now we can say the total number of ways we can get is 6 plus 4 is 10. 6 plus 4 is 10 by total number of outcomes is for each sided dice is 6. So 6 into 6 into 6 into 6 means 6 to the power of 4. So simply we can say 10 by 1296 means x is equal to 10. We are going to get the result. One more small example, which is the probability that a given cost integer lying between 1 and 100, both inclusive, means it is going to include both 1 and 100, is not divisible by 2, 3, 5. Means we have to see what is the probability that a given cost integer lying between 1 and 100, including both of them, is not divisible by 2, 3, 5. So we can say x is going to lie between 1 to 100. Then what is the probability x is not divisible by 2, 3, 5 is nothing but is 1 minus the probability that x is divisible by 2, 3, 5, which is probability of 2 plus probability of 3 plus probability of 5 minus probability of 2 into 3 is 6, and similarly minus probability of 3 into 5 is 15 minus probability of 2 into 5 is 10 plus probability of 2 into 3 into 5, which is 5 by 15 into 2, which is 30. Therefore, this is the probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection K plus probability of A intersection B intersection C. We are going to get this value, which is, if you don't want this one, which is minus 1 minus, you want each and everything. So if you do all these things, then we are going to get the result 1 minus 74 by 100, which is 0.26 is the correct solution of this question. If A and B are mutually exclusive, means I have already told you, whenever the A and B are mutually exclusive, means they are going to cover the overall sample space, means A union B is equal to yes. Means collectively exhaustive, then what is going to happen means here, because they are going to totally span the sample space, yes, so therefore we can say the probability of A plus probability of B is equal to 1, because we are going to add all the probabilities. Then what is the maximum value of P of A into P of B? We need to figure out. See, P of A plus P of B is equal to 1. So therefore, now I am going to assume P of A is equal to x, so P of B is equal to 1 minus 6. So now I want to know what is the maximum value of this one. So y is equal to P of A is x and P of B is 1 minus 6. So therefore y is equal to x minus x square. So divided by dx is equal to 1 minus 2x. So 1 minus 2x. Therefore 1 minus 2x is equal to 0. So if you solve this one, we are going to get x is equal to half. So now if you go for the again derivative, which is d square by dx square is equal to minus 2, which is less than 0. So therefore we are going to say that it is going to occur maximum value whenever x is equal to minus. So it is going to occur maximum value at x is equal to half. So therefore if you substitute here half into 1 minus half, we are going to get 1 by 4. So maximum value is nothing but now 1 by 4. Suppose there is a small question here. Suppose there is a batch C and an entire class. Suppose in a class there are so many batches. So we can assume there is a batch C which is going to have only this batch C students as mean is equal to mu C and sigma C is called as the standard deviation of this batch C. So now here P is called as the normalized marks score. Means these are the marks which are scored by the student with respect to this batch C. Suppose then with respect to entire class, the entire class has a mean is equal to mu and sigma is a standard deviation of the entire class. So now I am going to convert these marks for batch C to this overall entire class I want to convert. So how to figure out this one? See, the normalized marks scored by same student under this category, under the entire class, and this is the normalized marks stored by the with respect to the batch C. So we are going to convert this into this one. So how to do this one? In order to normalize batch C to entire class, the normalized score, Z scores must be equal. So therefore, whatever the Z value of this value should be equal to this value, which is P minus mu C by sigma C is equal to capital P minus mu by sigma. So if you compare with these two things, now we know the value of this value, this value, this value, this value, and we also know the value of this. So only unknown parameter is P. So we can figure out this value from P by using this formula. So now we can easily figure out the value of the capital P. Suppose P of A is the probability of failing in paper 1, whereas P of B is called as the probability of failing in paper 2. Then what is the probability of A by B? Is nothing but probability of failing in paper 1 and he already failed in the paper 2. That is the meaning of P of A slash B. And the probability of A and B is called as the probability of failing in both papers. So now I want to know what is the probability of A by B is called to probability of A into intersection B by probability of B. So if we do simplification, we are going to get probability of A into A intersection B is equal to probability of B into probability of A by B. Already told you the correlation variation is equal to CV. The CV is called as the coefficient of variation, which is it is a ratio of the sigma by B. The sigma is called as the standard deviation and V is called as the mean. So therefore, sigma is called as the standard deviation of speed of vehicles in a highway. Suppose in a highway, some vehicles are going to pass. Then what is the standard deviation of the speed of vehicles? And V is called as the mean speed of vehicles in a highway. So if you do the ratio of these two things, we are going to get the coefficient of variation. So CV is called as the coefficient of variation in the speed, which is the ratio of the sigma by mean. If suppose X and Y are two independent random variables, then what is the exponential of X into Y is equal to exponential of X into exponential of Y. I have already told you the covariance of X comma Y is equal to exponential of X into Y minus exponential of X into exponential of Y. As this value is equal to this value, if we substitute here, we are going to get is equal to 0. And similarly, if X and Y are independent, then definitely variance of X plus Y is equal to variance of X plus variance of Y. Whereas exponential of X square into Y square is nothing but here exponential of X square into exponential of Y square. This is the case only when the X and Y are independent. But as exponential of X square is not equal to exponential of X square, because exponential of X square is equal to integration minus into percent t X square into f of X dx. Whereas exponential of X is equal to integration minus into percent t X into f of X whole square. So because of that reason, we are going to say that these both are not equal. Here f of X is called as a probability density function. So if we want to know what is the probability for A to B range, then integration of A to B f of X into dx, this is called as the probability under this range. So if we want to know what is the percentage, just go for the multiplication with respect to 100. Suppose there are X and Y are the two random variables. So for X, mu X value is 1 and sigma X square is 4. So if we solve this one, we are going to get sigma X is equal to 2. Suppose in the question they are given the mu A is equal to minus 5. So we have to find what is the value of sigma Y we need to figure out. So they also given a condition which is probability of X less than or equal to minus 1 is equal to probability of Y greater than or equal to 2. So we are going to convert this into standard curve, which is Z less than or equal to X minus mu by sigma. So minus 1 minus 1 by 2. So therefore, to solve this one, for P, again Z greater than or equal to 2 minus of mu y by sigma y. So if we solve this one here, we are going to get Z less than or equal to minus 1 and Z greater than or equal to 3 by sigma y. See, only when these values for Z less than or equal to minus 1 and for Z greater than or equal to 1, then only because it is symmetric with respect to y axis, so this has to be greater than y. Means 3 by sigma y must be equal to 1. Then only we can say this both the probabilities are equal, otherwise they are not equal. So therefore 3 by sigma y should be equal to 1. So therefore if you solve this one, we are going to get sigma y is equal to 3. Suppose there is a X is a discrete random variable. Suppose X is a discrete random variable, like this in the question they are given. Suppose for X range from 1 to 3. For P of X for 1 is 0.3, for 2 is 0.6 and for 3 is 0.1. So if we do the summation of P of X, we are going to get as a 1. Then what is the mean for the random variables plus discrete random variables, which is X bar is equal to sigma X into P of X, means 1 into 0.3 plus 2 into 0.6 plus 3 into 0.1, we are going to get the mean. But if you want to know what is the standard deviation, it is under root over e of x square minus e of x whole square, means sigma x square into p of x minus sigma x into p of x whole square. So if you solve this one, we are going to get the standard deviation. But if you want to know what is the variance, just go for the square of this one, we are going to get the variance. Suppose there is a small example, which is consider an unbiased cubic dice with opposite faces colored identically and each face colored red, blue, green, such that each color appears only 2 times on the dice. If the dice is thrown twice, the probability of obtaining red color on the top face of the disc at least twice is. So there is a dice, so therefore unbiased dice is there. So for that, we are going to color the two opposite faces in the same manner, which are the colors are red, blue and green. So in the question they are asking that what is the probability that the top face is a red color at least twice, we need to figure out. So now there are 3 colors, red, blue and green. So now what is the probability of red? Because out of 6, 2 are same, so 2 by 6, 2 by 6 and 2 by 6. So now we have to see at least 2 times. So for as the dice is thrown 3 times, so we have to find what is the probability of obtaining red color in the top face at least twice. At least twice means minimum 2. At least 2. Just 2 means minimum 2 and maximum is 3. So therefore we can say here n is equal to 3 means total 3 cases are there, means 3 times we are going to throw, but r is equal to red color. So probability of red occurrence is 2 by 6 and the probability of not occurring red is something but 1 minus which is 4 by 6. So now at least twice means we can go either for x is equal to 2 plus x is equal to 3. So if you go for this one, NC2 into p square into q of n minus 2 plus here NC3 into p of 3 into q of n minus 3. So as I already know, we know the value of n, we know the value of p, we know the value of q. Substitute here, we are going to get the solution which is 0.259, we are going to get the solution. Suppose if A and B are 2 independent events, then what is going to happen? So probability of intersection B is equal to probability of A into probability of B, and probability of A by B is equal to probability of A, and probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. But we are going to replace probability of A intersection B is equal to probability of A into probability of B, and similarly probability of A complement intersection B complement is equal to probability of A complement into probability of B complement. We are going to get this equation. Suppose there is a small example like this. Suppose there are 3 vendors who are asked to supply a very high precision component. The respective probabilities of their meeting the strict design specifications are 0.8, 0.7, 0.5. Each vendor supplies one component. The probability that out of the total 3 components supplied by the vendors, at least one will meet the design specification is. At least one will meet the design specification means it is equal to 1 minus. So it is nothing but 1 minus. So no one is going to give the exact way of specified dimension of the object. Then we can say 1 minus of a dash into b dash into c dash. Therefore 1 minus a dash is nothing but 0.2, 0.3 into 0.5. So if we solve this one, we are going to get 0.97. Means at least this much amount of probability, at least anyone is going to give you the exact way of the specifications. Suppose there are one more small example, which is 2 players A and B alternatively keep rolling a fair dice. The person to get a 6 first wins the game. Given that player A starts the game, the probability that A wins the game is. So therefore here, see whoever the person is going to roll a fair dice, whoever the person is going to get the 6, that person is going to win the game. So now A is going to start the game, then what is the probability that A will win the game? So the probability of A is equal to, see, you can get the throw in the first row, in the first row only you can get the 6, or in the third row, in the third time you should get the 6, or in the 1, 2, 3, 4, 5, 6, in the 6th time also you can get the things. So now like this you have to go for this one. See, in the first case you should get, otherwise in the third case, otherwise you have to go for this case. So therefore for the first time is 1 by 6, but here he is not going to get the probability, means this is the failure is 5 by 6. So therefore 5 by 6 whole square into 1 by 6. Again this is 5 by 6 whole the power of 1, 2, 3, 4 into 1 by 6. So like this you have to go for the addition. This is nothing but a geometric way of infinite series. So therefore to take 1 by 6 common, we are going to get this value, we are going to get. This is nothing but a geometric series of infinite series. So if we do simplification, we are going to get 6 by 11 we are going to get. Now there is one more small example, which is consider the following probability mass function PMF of a random variable x, which is P of x comma q is equal to q if x is equal to 0, and it is equal to 1 minus q if x is equal to 1, and it is equal to 0 otherwise. So for these values 0 and 1, these are the range, and remaining everything which value is 0. If q is equal to 0.4, the variance of x is. So for a specified value of q, what is the variance of x we need to figure out. So here only x can go from 0 to 1. So when it is 0, we know the value of q which is 0.4. When it is equal to 1, we know the value which is 1 minus 0.4 is 0.6. So now we have to go for the variance of x, which is expression of x whole square is expression of x square minus expression of x whole square. So if we do this one, we are going to get 0.24. We are going to get the solution. Suppose we are going to solve another question, which is two coins R and S are tossed. Two coins R and S are tossed. The four joint levels HR, HS, TR, TS, HR, TS and TR, HS have probability 0.28, 0.18, 0.30, 0.24 respectively, where H represents the head and T represents the tail. Then, see in the question they are given there are two coins R and S. See the head of R, head of S. Like this they are given the probabilities. So now H represents the head and T represents the tail. Then what we need to figure out? Then we have to figure out the each individual one we need to figure out. See here, this is the S coin and this is the R coin. So for S coin, the head is HS, tail is TS. For R coin, the head is HR and the tail is TR. So the question they are given HS, HR which is 0.28, TS, HR they are given which is 0.30, and HS, TR they are given 0.24, and TS, TR they are given 0.18. So if we do some summation of these two things, we are going to get 0.58. If we do the summation of these two things, we are going to get 0.42. And similarly, if we do the addition of these two things, we are going to get 0.52. And if we do the addition of these two things, we are going to get 0.48. And if we do the summation of these two things, we are going to get 1. And if we do the addition of these two things, we are going to get the value of 1. So from this we can say the probability of HR. The probability of HR is nothing but here the probability of head in the R coin, which is 0.558, whereas the probability of tail in the R coin, which is 0.42. And similarly the probability of head S coin is which is 0.52, and the probability of tail in the S coin, which is 0.48. So you can see clearly here the both has to be 0.5, whereas but they are different. So in the R coin, the probability of head is not equal to probability of 10. So therefore we can say this is unbiased time. So therefore S and R. So you can see for the R coin they both are different. For S coin also they both are different. So therefore we can say S and R coins are biased coins. So therefore we can say these coins are said to be biased coins. And also the probability of HR intersection HS means both HR and also HS. This is 0.028. So if you do the independent property, which is HR into HS, then it has to be 0.58 to 0.52, which is 0.3016. But this is not equal to this value. So therefore probability of HR intersection HS is not equal to probability of HR into probability of HS. So therefore we can say these are also dependent coins. So therefore we can say the coins are dependent and also biased coins. So we can conclude that the coin tosses are biased and also these are dependent coins. Plus one coin is going to depend upon the outcome of the other one. So the question they are given like this, which is X and Y are two random independent events, and probability of X is equal to 0.4 and the probability of X union Y complement is equal to 0.7. Then we have to find what is the probability of X union Y we need to figure out. So in the question they are already given X and Y are the random events. They are given probability of X and also probability of X union Y complement. So we have to find what is the probability of X union Y. So already they are given probability of X union Y complement is equal to 0.7. So by using the probability of X plus probability of Y complement minus probability of X intersection Y complement is equal to 0.7. So probability of X plus this is nothing but 1 minus probability of Y minus probability of X into probability of Y dash is nothing but 1 minus probability of Y by using the property of independent property. So if we do the simplification, we are going to get P of X plus 1 minus P of Y, and if we do the multiplication, we are going to get minus P of X plus P of X into P of Y is equal to 0.7. So this both are going to get cancelled. Finally we are going to get P of Y minus probability of P intersection Y. It is nothing but this is nothing but P of X intersection Y. So therefore this we are going to call it as the P of Y minus probability of X intersection Y is nothing but now 0.3 we are going to get. So therefore but P of X and Y is equal to P of X plus P of Y minus P of X intersection Y. So but we know this value which is 0.3 and P of X also we know which is 0.4. So 0.5 plus 0.3 is equal to 0.7. So 0.7 is the correct solution of this question. Suppose two random variables x and y are distributed along according to the relation which is f of x comma y is nothing but here x plus 5 for the range of x lies to 0 to 1 and the y ranges from 0 to 1 and it is equal to 0 otherwise. Then what is the probability of x plus y less than or equal to 1 we need to figure out. This is the thing that we need to figure out. So therefore probability of x plus y less than or equal to 1 is equal to here the probable density function which is f of x comma y dx to dy where y is going to range from. So this is nothing but a straight line. So therefore straight line is nothing but y is equal to 0 to 1 minus x. And similarly x is going to range from 0 to 1. We need to figure out like this one because y can range from only 0 to 1 minus x whereas x can go from 0 to 1. So like this we are going to get the exact way of doing this one. So there is one more example which is the probability of a defective bolt is 0.1. Means a defective bolt has a probability of 0.1. The standard deviation for the distribution of the bolt in a total of 400 is. So we have to find what is that. The standard deviation for the distribution of the bolts in a total of 400 we need to figure out. See the probability is nothing but defective is equal to 0.1. So non-defective will be 1 minus 0.1 is 0.9. But total number of things are 400. Standard deviation is equal to sigma is equal to under root over n into p into q. Already I told you this formula in the terms of the binomial distribution. So therefore np into 1 minus p nothing but npq. N value we know, p value we know, q value we know. Just do simplification we are going to get the standard deviation which is 6. One more small example we are going to learn which is a 6-faced dice is so biased that when thrown it is twice as likely to show an even number than an odd number. If it is thrown thrice, the probability that some of the numbers appeared is odd is. The question that I mentioned that a 6-faced dice is so biased, means it is a biased curve that when thrown it is twice as likely to show an even number than an odd number. Means it is going to show 2 times more even number than an odd number. If it is thrown thrice, the probability that the sum of the numbers appeared is odd is. So we have to find what if we are going to throw it thrice, then what is the sum of the numbers appeared is odd number we need to figure out. The probability of showing even number is twice. So out of 3, twice means 2 by 1 plus 2 which is 2 by 3. So the probability of showing odd number is the reverse one. So 1 by 1 plus 2 which is 1 by 3. Means if you take 3 attempts, out of that 2 times it is nothing but even number. So 2 by 3 and only 1 is odd number. So 1 by 3. So for sum to be odd, so sum can be only odd when even plus odd or even plus odd plus even or odd plus even or odd plus odd. Then only these conditions only. So if you take 2 even numbers and odd number, if you rearrange this one, we are going to get 3 formats. And if you take odd, because odd plus odd is even and even plus odd is again odd. So only in these 4 formats only we are going to get the odd number. So therefore simply as these 3 are equal, so 3 into even number is again we know which is 2 by 3 into 2 by 3 into 1 by 3. So we are going to get 3 times of 2 by 3 into 2 by 3 power 1 by 3 plus your odd number is 1 by 3 into 1 by 3 into 1 by 3. So if we do this one we are going to get 13 by 27 we are going to get the exact solution. Suppose that's a small example which is if the probability of a bad reaction for a certain induction is 0.001, then the probability that out of 2000 individuals more than 2 will be getting a bad reaction is. So therefore see out of 2000 individuals more than 2 will be getting the bad reaction is. So how many number, what is the maximum probability we need to figure out. So therefore now since the probability of occurrence is very small, this follows Poisson distribution. Means whenever the probability is very small, then we are going to use the Poisson distribution that we are going to use, which is lambda is equal to n into p. So here lambda is equal to n into p is nothing but here n is 2000 individuals and p is nothing but 0.001 which is equal to 2. So therefore the probability that more than 2 will get a bad reaction is nothing but then it is nothing but here always x lies between 0 to infinity. So therefore 1 minus of p of 0 plus p of 1 minus p of 2. So only these things means greater than 2 means p of 3 plus p of 4 like this. So therefore 1 minus p of 0 plus p of 1 minus p of 2. So already I told you the formula of this p of x is equal to e to the power of minus lambda into lambda to the power of x by x factorial. So if you substitute all these things and do simplification we are going to get, this is the solution we are going to get. Suppose there is a small example which is a particle moves along the curve. The curve says x is equal to 2t square, y is equal to t square minus 4t and z is equal to 3t minus 5, where t is in minutes. The component of velocity at t is equal to 1 in the direction of I minus 3j plus 2k is. So what is the velocity of component at t is equal to 1 in the direction of this thing we need to figure out. So we can say r bar is equal to xi cap plus yj cap plus zk cap. So we can write in terms of r cap. But velocity is equal to rate of change of distance. So v is equal to dr by dt. So v is equal to dr by dt. So if you do this one, we are going to get the velocity. So velocity component at t is equal to 1. If you do this one, we are going to get, if you keep t is equal to 1, we are going to get this one. But now the component of velocity in the direction of this thing we need to figure out. So what is the component of this one? So let me assume this is a bar and this is a b bar. So I want to find what is the component of a bar in the direction of b bar, which is the only way thing is mod a bar at constant, which is equal to a bar dot b bar by mod of b bar, means this dot product of this dot product. You have to do the dot product of these two vectors by magnitude of this vector we need to figure out. So therefore v bar dot product of this vector by magnitude of this vector we need to do this one. So finally we are going to get the solution. Suppose there are two dice are thrown simultaneously, the expected sum of the numbers shown up is, suppose two dice we are going to throw simultaneously, then the expected sum of the numbers shown up is, what is the expected sum of the numbers we need to figure out. So therefore now expected sum. So let the numbers appear on the dice are x1 and x2. So we are going to assume that x1 and x2 are the numbers which are going to occur on the dices. So the expression of sum is equal to expression of x1 plus x2, because we are going to add these two things, numbers, then only we are going to get this sum. What is the expression of this x1 plus x2, which is equal to expression of x1 plus expression of x2, because if we do the two components, then only we are going to get this sum. So therefore it is expression of x1 plus x2 is equal to expression of x1 plus expression of x2, as both are equal. So therefore we are going to assume that both are equal, so therefore they will be equal to e to the power of x is equal to e to the power of x, 2 into e to the power of x. So therefore now, but e of x is equal to sigma I is equal to 1 to 6 xi into p of xi, because the probability for there are total 6 dices. So expression is equal to, there are 6 dices, so probability of each number is nothing but same, and also we are going for sigma I is equal to 1 to 6 xi into p of xi, we are going to get in this manner. So therefore finally we are going to get now 7 by 2 we are going to get. So if you substitute here in this one, we are going to get 2 into 7 by 2 is nothing but 7. So this is the expected sum we are going to get for this question. So now suppose dt by dt is equal to dt by d capital T by dt is equal to k into t minus t naught, where this is called as the Newton's laws of cooling, where t naught is called as the surrounding temperature in degree centigrade, where t is called as the boil temperature and t is called as the time in minutes. So by this rate it is going to get decay. So dt by dt is equal to k into t minus t naught. If happening or not happening of one event does not affect outcome of other event, then they are known as the independent events. I have already told you, independent events means the event of one thing is not going to, is the occurring or not occurring of one event is not going to affect the occurring or non occurring of the other event B. Then we are going to say that these two events are said to be independent events. So if happening or not happening of one event does not affect outcome of other event, then they are known as the independent events. At least means minimum and at most means maximum. See, at least means minimum. That is the minimum value that we are going to consider. So at most means that is the maximum value. That is the maximum value. So at least means minimum and the at most means maximum. That is the maximum value which we are going to get. If you throw n dices, the expected sum is given as p of x is equal to n into 3.5. This is a very big standard formula, which is if you are going to throw n dices, the expected sum is, suppose if you are going to throw n dices, then what is the expected sum, which is n into 3.5. If n is equal to 2, we are going to get 7. If you throw n coins, the expected heads is given as, so which is e of x is equal to n by 2. If you are going to throw n coins, the expected number of heads, which is n by 2, we are going to get. Suppose with a small example, which is, suppose xi is equal to marks. So for xi is equal to marks, for correct question and the incorrect question. Means for a question, the marks are with this one. So correct marks are also there and also incorrect marks are also there. Then we can figure out the probability of xi. So the probability of xi also we can easily figure out. Those two events A and B said to be equally likely if probability of A is equal to probability of B. Means if the probability of event A is equal to probability of event B, then only we can say these two events are said to be equally likely. Here, this indicates that suppose there is a xi marks column and the probability of xi. So for the correct question there will be some marks, and for incorrect questions there will be some marks. And also the probability of correct is also there will be some probability, and for incorrect also there will be some probability. So based on this we can figure out the expectation and also variance. See, for mutually exclusive events, I have already told you the probability of A union B is equal to probability of A plus probability of B. As there is no probability of A intersection B is always equal to 0, so because of that only we can say the probability of A plus probability of B. And similarly, the probability of A union B union C is equal to probability of A plus probability of B plus probability of C. Whereas even union E2 complement is equal to E1 dash intersection E2 dash. And similarly, even intersection E2 whole complement is equal to E1 complement union E2 complement. Suppose if all the events are independent, what is going to happen? The probability of A intersection B intersection C is equal to probability of A into probability of B into probability of C, and similarly probability of A intersection B is equal to probability of A into probability of B, and probability of A intersection C is equal to probability of A into probability of C, and probability of B intersection C is equal to probability of B into probability of C, and probability of A intersection B dash is equal to probability of A into probability of B dash, and probability of A complement intersection B is equal to probability of A complement into probability of B, and probability of A complement intersection B complement is equal to probability of A complement to probability of B complement. It's a very simple things. E of x denotes expected value or average value of the random variable x. Means E of x means it is called as the expected value or average value of the random variable x, while Vx denotes the variance of the random variable. Means E of x is also called as the expected value or the average value of the random variable, and V of x is called as the variance of the random variable. So basically the discrete distributions are the general discrete distribution, binomial distribution, hypergeometric distribution, geometric distribution, Poisson distribution. All these are going to come as a category of the discrete distribution. See, E of x is the expected value of x, and it is similar to an average value of x after infinite number of trials. So E of x is sometimes also written as mu of x. Means I have already told you expectation of x is nothing but it's the average value of random variable x. Means if you are going to consider the number of trials as infinity, then at last we are going to get which is called as the expected value of x. So E of x is the expected value of x, and it is similar to an average value of x after infinite number of trials. So E of x sometimes we are going to write as mu of x. V of x represents the variability of x, so it is sometimes as sigma x whole square. I have already told these points. So Poisson distribution is used to approximate binomial distribution when n is very large and p is very small. Means Poisson distribution is used to approximate binomial distribution when n is very large and p is very small. See, whenever n is very large and p is very small, we are going to approximate the binomial distribution into a Poisson distribution. Means whenever n is very large and p is very small, we are going to prefer the Poisson distribution rather than the binomial distribution, because we are for a Poisson distribution always the n is very higher and the p is very small, because the binomial distribution cannot handle these things. So because of that reason only we are going to prefer the Poisson distribution rather than the binomial distribution where n is very large and p is very small. So notice that direct computation of NCS to the power of x into 1 minus p over the power of n minus x may be impossible when n is very large and p is very small. Yes, see, already I have told this point, which is says binomial distribution cannot hold n is equal to large and p is equal to small. That is the reason we are going for the Poisson distribution. So hence we resort to a Poisson distribution with lambda is equal to n into p. So we are going to assume lambda is equal to n into p for the Poisson distribution, which is lambda is equal to n into p, which is lambda is called as a mean is equal to n into number of trials into probability of the event of occurring successive event. Now we are going to learn about the continuous distribution, which are the general continuous distribution, uniform distribution, exponential distribution, normal distribution, and a standard normal distribution. All these are going to come under the category of the continuous distribution. See, positive correlation means if value of one variable is increased, then the value of other variables also increases. Negative correlation means if one variable is increased, then the value of the other variable decreases. Means positive means if one is going to increase, the other is going to get increase. Negative correlation means if one is going to increase, then definitely the other variable must decrease. If variation of x does not affect on y, then there is no correlation. Means if one is going to suppose if one is going to get changed, if there is no change in the other variable, then we are going to say that there is no correlation between these two random variables. If one is increasing, other is also increasing, there is a positive correlation between these two random variables. If one is increasing and other is decreasing, then there is a negative correlation between these two random variables. But if one is increasing and there is no effect on the other random variable, then we are going to say that there is no correlation between these two variables. This part is also, I told you, the coefficient of correlation, which is R is equal to P by sigma x into sigma y. Or also, we are going to call it as the covariance of x comma y by under root over variance of x into variance of y is equal to sigma x into y by under root over sigma x square into sigma y square. This point also I have already told you. And if R is going to lie between, see, R is always going to lie between -1 to 1. If suppose R is equal to 0 means there is no correlation. If R is equal to 1 means the maximum value, which is a perfect positive correlation. If R is equal to -1 means perfect negative correlation, means minimum value. But if R lies from 0 to 1, then we say positive correlation. If R lies from -1 to 0, then we say negative correlation. Means if it is R is positive, R is negative means negative correlation. If it is equal to 1 means perfect positive correlation. If it is equal to -1 means perfect negative correlation. If R is equal to 0 means there is no correlation between the terms x and y. So now the line of regression, I have already told this point, which is suppose there is a data from x1 y1 to up to xn yn. Then the line joining this point, which we are going to call as the y is equal to x a plus bx. Then I have already told you these points are going, this line is going to satisfy the mean points. This line is going to pass the mean point, which is x bar from y bar. So replace y and x by y bar and bx bar. So y bar is equal to a plus bx bar. So y bar we can write sigma y by n, and x bar we can write sigma x by n. So if we get cross multiplication of n, we are going to get sigma y is equal to n a plus b into sigma x. We are going to get probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. Whereas probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. All these things are the basic concepts. We can replace probability of A is nothing but 1 minus probability of A dash, and we can replace probability of B is 1 minus probability of B dash. So now, if you do simplification, we are going to get in this manner also we are going to get. Suppose there is odd in favor of even. If it is A by B, then what is the probability of event A? And I told you favor means this is the A. This is the A. So A by. Then you have to go for the addition of these two things. Then only we are going to get the net outcome. Net number of outcomes in the experiment. That means these are the favor, these are the unfavor. So if you want total A plus B. If you want probability of E bar, E dash means unfavor events B by A plus B. As A plus B indicates that the total number of outcomes present in the event. So these are the very important points. Listen carefully. The properties of the expectation and the variance, which are suppose x1 and x2 are the random variables and A and B are the constant values. Then these are the different rules, which are the expectation of ax1 plus b is nothing but A into expectation of x1 plus b. So variance of ax1 plus b is equal to A square into variance of x1. Expectation of ax1 plus bx2 is equal to A into expectation of x1 plus b into expectation of x2. Whereas variance of ax1 plus bx2 is equal to A square into variance of x1 plus b square into variance of x2 plus 2ab into covariance of x1 comma x2. As covariance of x1 comma x2 is equal to expectation of x1 into x2 minus expectation of x1 into expectation of x2. Already this point also I already told you. If x1 and x2 are independent, then definitely the covariance of x1 comma x2 is equal to 0, because expectation of x1 into x2 is equal to expectation of x1 into expectation of x2. Then we are going to get the variance of ax1 plus bx2 is equal to A square into variance of x1 plus b square into variance of x2. But there is this factor plus 2ab into covariance of x1 x2 will become 0. So only these two terms are going to get remain. I have already told you positive skewed distribution, symmetric distribution, and also negative skewed distribution. In a symmetric, everything is going to get same. In a positive, mean greater than, median greater than, mode. But in a negative, we have to just interchange these two things, which we are going to get mode is greater than, mean is greater than, mean. If f of x is a continuous probability density function of a random variable x, then I have already told you the probability of between a to b, when it can be lesser than or equal to in any range, will be always from a to b f of x into b of x, where f of x is called as a continuous probability density function. Then only we are going to get the overall probability in this range. Suppose if x and y are independent variables, I have already told you expectation of x into y is equal to expectation of x into expectation of y. whereas covariance of x into y is nothing but 0, because covariance of x comma y is nothing but here we are going to get exponential of x into y minus exponential of x into exponential of y. This becomes 0. And variance of x plus y is equal to variance of x plus variance of y. Whereas exponential of x square into y square is equal to exponential of x square into exponential of y square, but it is not equal to b square. Standard deviation is affected by scale but not by shift of origin. Means standard deviation is affected by scale but not by shift of origin. Means if you are going to do some scalar way, means we are going to either do the multiplication like that, then we are going to get the scalar net is also going to get changed. Means if you go for a scalar multiplication of each and every parameter, coordinate values are going to change by some scalar, definitely the standard deviation is also going to get changed. But with the shifting of origin it is not going to get changed. Just we are going to shift the graph, that's it. Suppose there is a x, these are the coordinates of the x. So for this we are going to find the mu x and sigma x. And similarly there is a set y, these are going to contain the y terms. It is going to have mu y and also sigma y, means mean and also standard deviation of y. Then I have already told you, which is the line joining this point is nothing but y is equal to axi plus b. So now we can replace this by nothing but here that mean values, which are y is equal to a mu x plus b, means exponential of y is equal to a into exponential of x plus b. And similarly, if you want to know what is the variance of y is equal to a in, you can say the standard deviation of y is equal to a into the standard deviation of x. But if you want to know what is the variance of y is equal to a square into variance of x. Thing is mentioned about events, then by default they are independent. See, if suppose in the question they are not mentioning about the events, what is their nature, then definitely by default you have to assume that these are the independent events. Suppose a program consists of two modules executed sequentially at f1 of t and f2 of t respectively, denotes the probable density functions of time taken to execute the two modules. The probable density function of the overall time taken to execute the program is convolution of both functions, which is integration of 0 to t f1 of x into f2 of t minus x into dx. Means if one is going to take time f1 of t, then other program is going to take a time f2 of t, and if you want to do both of them, it is nothing but the convolution of the both of the things. Program consists of two modules executed sequentially at f1 of t and f2 of t represents respectively denotes the probable density functions of time taken to execute the two modules. The probable density function of the overall time taken to execute the program is a convolution of both of the functions. Probability of execution B is equal to probability of A into probability of B only when A and B are independent events. And similarly, probability of A union B is equal to probability of A plus probability of B minus probability of intersection B. So from this we can simply say that the probability of A union B always less than or equal to probability of A plus probability of B. Independent events and mutually exclusive events are unrelated properties, so never relate them, because for independent events means probability of A division B is equal to probability of A into probability of B, but for mutually exclusive events probability of intersection B is equal to 0. So these are two different things, so we don't have to relate them because they are different. See, always A intersection B is always less than or equal to A, means it is a subset of less than or equal to A. So therefore, similarly we can say the number of elements in A intersection B is always less than or equal to number of elements of A. Similarly, the probability of A intersection B is always less than or equal to probability of A. Similarly, the probability of A intersection B is also less than or equal to probability of B in the same manner. The measure of skewness is dependent upon the amount of dispersion. It's a very important point. The measure of skewness is dependent upon the amount of the dispersion. See, variance of x is equal to exponential of x square minus exponential of x whole square. This value is always greater than or equal to 0. When A and B are independent events, I have already told you the probability of intersection B is equal to probability of A to probability of B, and probability of A event occurring when the event B is already occurred is equal to probability of A, and the probability of event B occurring when the event A is already occurred is equal to probability of B, and probability of A intersection A complement intersection B complement is equal to probability of A complement into probability of B complement. And similarly, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B is equal to, because we are going to replace probability of A intersection B is equal to probability of A into probability of B. So we are going to get this relation. To error in hypothesis testing is acceptance of the null hypothesis. When it is false, it should be rejected. Means whenever this hypothesis is going to give you false, means you should reject them. If it is a good, means you have to accept it. The expression of Ax plus B whole square is equal to, just do the expression of this one, we are going to get expression of A square plus B square plus 2abx. So therefore we are going to get A square into expression of x square plus 2ab into expectation of x plus b square, we are going to get this one. Suppose there is a small question. Suppose there is a bag containing 4 red balls and 4 blue balls. So 4 balls are drawn. R is equal to red balls and B is equal to blue balls. So from this we are going to draw the 4 balls are drawn, one by one from the bag. Then the probability that the drawn ball are in alternate color. So we are going to get the alternate color we are going to get. So what is the probability we are going to see? See, let us assume the first ball is red. So we are going to assume that first ball is a red ball. So therefore we can say 4 by total is 8. 4 by 8 into. We are removing the red. So next ball is we are going to remove the blue ball. So 4 by total number is 7. Now we are going for the red. So total now there are 3 red balls. So 3 by total number is 6. And then we are going to go for the another one, which is the 3 there. Already one is removed, so 3 by 5 we are going to get. So this is called as a probability in the first ball is red. Let us assume the first ball is blue. Then what is going to happen? This is 4 by 8. Again is 4 by 7. So this will become 3 by 6. Again 3 by 5 we are going to get. So if you do this one, we are going to get 3 by 35. But we have to go for the addition of two things. So therefore we are going to get the net result is 6 by 35. We are going to get the net result. Suppose limit x tends to infinity 1 plus x square whole the power of e to the power of minus x, we need to figure out. So now what I am going to do is I am going to assume x is equal to infinity in this equation. So 1 plus x square is nothing but 1 plus infinity square is nothing but infinity. So this will become e to the power of minus infinity will become 0. So infinity is the power of 0 form we are going to get. So now what we are going to do is now we are going to make the logarithm on the both sides. Then we are going to get log y is equal to limit x tends to infinity e to the power of minus x into log of 1 plus x square. Now if you are going to substitute this log, this infinity, this will become 0 into infinity. So 0 into infinity is nothing but we can write in another form which is infinity by 1 by 0, which is nothing but infinity by infinity form also we can write. So same thing I will give here. Log y is nothing but limit x tends to infinity log of 1 plus x square by e to the power of x. So this is a infinity, this is also infinity. So infinity by infinity form is nothing but indeterminate form. So now we have to apply the LH hospital rule we are going to apply. So now if you apply log y is equal to limit x tends to infinity, the differentiation of this one will become 1 by 1 plus x square into 2x. Again do the differentiation of this one we are going to get e to the power of x. Now substitute the x tends to infinity. This will become infinity and this is also infinity. So again this is in the indeterminate form. And now again we have to apply the this LH hospital rule, and then if you substitute that x tends to infinity, we are going to get a final value 0. So now if you take the anti-log, we are going to get y is equal to e to the power of 0, which is nothing but 1. So y is equal to 1 is the correct solution of this question. Suppose f of x is equal to mod x, continuous at x is equal to 0, not differentiable at x is equal to 0, and has absolute minimum at x is equal to 0. Yes, I have already told you that f of x is equal to mod x, it is going to continuous at x is equal to 0, and also it is going to have absolute minimum at x is equal to 0, but it is not differentiable because for 0 plus its derivative is plus 1 and for 0 minus its derivative is minus 1. So because of that reason only the derivative is going to exist only when the right hand derivative is equal to left hand derivative. But here at this point is unequal, so because of that reason only we can say the derivative is not going to exist at x is equal to 0. Fourier series is applied for only periodic signals. So for only periodic signals only we are going to apply this Fourier series. Means we can write any periodic signal in the form of the sine and cos terms. So delta f is always a vector function, means a gradient of a scalar function will be always a vector function and it is in the increasing direction of a function. So the gradient of a constant scalar function is a 0 vector. If it is a constant value, means some numerical value, then definitely it will be equal to 0. But if you want to know what is a unit vector, then del f by mod of del f. It is a unit normal vector to the surface. Argument of the complex number theta calculated with respect to the positive reference axis always. Yes, argument is nothing but with respect to the positive x-axis only we are going to calculate the angle theta. So variance of x is equal to expectation of x square minus expectation of x whole square. Suppose there is a periodic function f of x, the time period of 2 pi. So you can say T and this is pi, this is also pi. The total period is 2 pi. So we can write the Fourier series expression which is f of x is equal to a naught plus sigma n is equal to 1 to infinity en cos n x plus dn sin nx. So I want to find what is the value of a naught, which is 1 by time period, which is 2 pi integration of overall thing from minus pi to pi, means which is going to converge to minus pi by 2, the value is 1 dx. So if you solve this one we are going to get 1 by 2. If you want an, is nothing but 2 by time period, which is 2 by 2 pi into integration of overall value from minus pi to pi means minus pi by 2. Here this function, this value which is nothing but f of x, that f of x is nothing but 1 here into cos n x dx. So if we cos n x dx, we are going to get with this value. But bn, if you do a simplification, because you can see clearly this is an even function. This is basically an even function. So you can see clearly this is the even function. So for even function, so even into odd, because sin is an odd function, so even to odd is nothing but odd function. So definitely we are going to get bn is equal to 0. So these are the values we are going to get these things. So basic formula is f of x is equal to a0 plus sigma n is equal to 1 to infinity an cos n x plus bn sin x. So a0 is equal to here 1 by time period integration of minus for over time period here f of x into d of x, and also here n is equal to here 2 by time period integration of over time period, which is f of x into cos n x dx, and similarly bn is equal to 2 by time period integration of over time period here f of x into sin n x dx. So limit x tends to pi plus cot x is nothing but plus infinity, but if you go for x tends to minus pi minus, we are going to get cot x as minus infinity. So therefore these two values are different. So whenever there is a difference means there is a discontinuity. Therefore we can say the limit is not going to exist at pi for cot x function. You can see clearly this is a tan function. So tan function for this one you can see clearly now tan function. This is a 0 pi by 2 pi. This is a tan function. So if you do the reciprocal of this one, we are going to get the cot function. So here this is 0 plus. So therefore definitely 1 by 0 is nothing but infinity. So this is a infinity to 0. And similarly this is 0 minus means 1 by minus 0 is nothing but plus 1 by small amount of negative is nothing but minus infinity. So minus infinity like this we are going to get. So for pi plus the cot value will be plus infinity, for pi minus the cot value will be minus infinity. So therefore there is a discontinuity for the cot function. So because of that only the limit is not going to exist at x tends to pi for a cot function. Whenever the limit x tends to a plus f of x is not equal to f of a, then f of x is not continuous at x is equal to a. Means if this is the limit is not going to equal, then only we can say that it is not continuous function. If it is a continuous function, definitely the limit x tends to a plus f of x is equal to limit x tends to a minus f of x is equal to f of x. Then only we can say the function is a continuous function. Suppose there is a question like this. Suppose we want to do the integration from 0 to pi x into sin to the power of 4x into cos to the power of 6x dx we need to figure out. For this integration value we need to figure out. So now what I am going to do is, already I have told you, integration of a to b f of x dx is equal to integration of a to b f of x minus of a plus b. We can do this one. So therefore here we are going to replace. So we are going to replace now. What we are going to do is 0 plus pi minus x means a plus b minus x also we can replace. So therefore 0 plus pi minus x means for integration of 0 to a f of x dx is equal to integration of 0 to a f of 0 plus a minus x means a minus x dx also we can write this one. So therefore 0 to pi, here 0 plus pi is pi minus x. So replace x by pi minus x. So sin pi minus x is nothing but again sin x, cos of pi minus x again cos pi. So same thing we are going to get. So if take the split this one, we are going to get in this manner we are going to get. So here this is also I, this is also I. So I plus I is 2i. 2i is equal to pi into integration of 0 to pi. So sin the power of 6x into cos the power of 4x into dx. So now I is equal to pi by 2 into integration of 0 to pi sin 6x into cos 4x dx is equal to pi. So therefore now you can take this off, you can take upper, in the upward also you can take this one. So pi into integration 0 to pi by 2, because this is a basic one in the integrations I have already told this concept. So therefore sin the power of 6x into cos the power of 4x into dx. So now you can use this formula, which is I is equal to pi into this, take the minus 1, so pi into 3 into 1, and take the minus of this one, so 3 into 1 by, now 6 plus 4 is 10, so 10 into 8 into 6 into 4 into 2 into, because both are even, go for pi by 2, then we are going to get, this is the solution we are going to get for this question. The normal distribution is a limiting form of the binomial distribution if n tends to infinity and neither p nor q is small. So the normal distribution is a limiting form of the binomial distribution if n tends to infinity and neither p nor q is small. See, but I have already told you, for a Poisson distribution, here n is very large and also p is very very small. But here for in order to make the binomial distribution to normal distribution, definitely n should be always greater than infinity, and also here p nor q means both p and q are not a small things. Now z is equal to sin of h of b plus iv is nothing but here sin h of u plus iv we are going to replace by w. So now you can take w is equal to sin h inverse of z. So take the derivative with respect to z. So dw by dz is equal to sin h inverse of z is nothing but 1 by under root over 1 plus z square. It's a basic formula of the differentiation of the sin h inverse x is equal to 1 by under root over 1 plus x square. So by that formula we are going to get this one. So w is not analytic at z is equal to plus or minus I, because if you substitute plus or minus I, we are going to get 1 by 0 is nothing but infinity we are going to get. So therefore we can say simply this, the derivative is not going to exist at z is equal to plus or minus I, means it is not analytic at these 2 points, means the function w is not going to exist at these 2 points. Or we can simply say if the derivative is not going to get exist, means simply we can also say that this function is not going to define at these 2 points. So we can say that w is not analytic at z is equal to plus or minus I. So sin h of a plus b is equal to sin ha into cos hb plus cos ha into sin hb. The same as the basic sin of a plus b, sin a into cos b plus cos a into sin b, same as that formula. Suppose it's a small example, x divided by dx plus y is equal to x cube. So you can see clearly here dy by dx is equal plus y by x is equal to x square. So now this is called as the linear differential equation, because in the format of the dy by dx is equal to py is equal to q. So like this, in the format of that thing is present. So we can say it is a linear differential equation. Suppose there is I want the integration from 0 to 1 x5 is about 5 into under root over 1 minus x square whole cube dx. I want to figure out this value. Let me assume x is equal to sin theta. Then what I am going to get here? Then when x is equal to 0, theta is equal to 0. When x is equal to 1, theta is equal to 5 by 2. So here in place of x substitute sin theta whole to the power of 5. Here 1 minus sin square theta means cos square theta. So cos square theta whole to the power of 3 means cos square theta. We are going to get. So now if you do a simplification of this one by basic formula, we are going to get 1 by 24. We are going to get the solution. So the variance of 3x minus 2y plus 11 by 7. I want to do this formula, which is 3 square 9 into v of x plus 2 square 4 into v of x. The variance of constant is always equal to 0. Suppose there is a box which contains 4 white balls plus 3 red balls. So first ball removed is white. So we are going to remove the first ball is white. The probability of second removed ball is red. Suppose the first ball is white, then the probability of second removed ball is red. Means already we have removed one ball as white. Means the net balls present after the first one is 3 white balls plus 3 red balls after the first removed. Now what is the probability that the second ball is red? Means 3 by 4 is 6. So 3 by 6 is nothing but 1 by 2 we are going to get. Means 3 chances for red, the total number is 6. So 3 by 6 is nothing but 1 by 2. So probability of second removed ball is red when the first ball is already removed, which is white. Limit x to infinity sin x by x is nothing but 0, because here I have already told you the sin function is always goes to range from minus 1 to plus 1, but as x can go up to infinity, so find by infinity value will be always equal to 0. Whereas limit x to infinity sin 2x by x, same thing. Similarly sin 2x is also going to range from minus 1 to plus 1, whereas x tends to infinity, so anything by infinity will be always equal to 0. Basically these are the conditional probability. So first we have to satisfy the condition, then we have to go for the next one what to do. So after satisfying the condition only, then we have to go for the probability of the remaining things that we need to figure out. So these are some of the rough ideas. In this lecture basically I have discussed some of the important formulas of probability and also some of the crucial examples which are basically asked in any competitive examinations. So these are some of the important concepts or some of the important numerical functions I have discussed. So how they are going to ask an examination. So if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, a direct notice comes from the If any improvements are in our lectures, then please do comment in the comment section. We will definitely get all these improvements in the coming lectures. Thank you so much for watching this lecture. Please take care and bye bye.